Hello World program on Java. So let us go for our first program to be written and to be executed on our Java Eclipse IDE.
On the Eclipse editor, we are going to type our code on to display the hello world string. In the package explorer, we are going for the right click, new and Java project. Giving the name as my hello world. You can give any other name here. So here we are going for this Java SE 1.8. All the things have been set. Now going for next. So it will create one src folder, going for finish. So my hello world has got created. This Java project has got created. On this src, we are going for this right click, new, and then going for this package. Giving the name as com.demo.hello world. com.demo.hello world. So that is my package name. We are going for finish. Then on this package, going for right click, then new, then going for class. It will go on creating a Java class. So let it be hello world. This class name and the file name must be same. So here you can find that we have given the name hello world with H and W capital letters. Rest letters are in the lowercase. Then the hello world.java will be created, and that will be having the same name as that of the class name. The package name has got displayed here. So under this, we're going to create one function, that is a main. I'm not going to type the full main prototype. We're going for this, we'll type this main and then control spacebar. We're using the Eclipse IntelliSense here. So that is the main method, which will have the prototype, that is public static void main string array args. So the respective function has got printed. So now we are going for this sysout. I shall not go on typing our system.out.println. I shall type only sysout and then control spacebar. So we are using Eclipse IntelliSense. So here we are typing here hello world. So in this way, the respective program we have typed. So here public class hello world, the name of the class is hello world. The hello world must be same as that of the file name. So the file name is hello world.java. We're going to save that one. And the first function which will start its execution is known as the main function, which will have the prototype, that is public static void main string array args. Obviously this args can be changed because it is nothing but one string array object. And instead of writing this public static, also you can write static public. So that is also allowed. So that is also allowed, but it is our common practice to write public static. So public means this particular function is accessible from outside of the class, and static means this particular function will have a single instance irrespective of the number of objects we are going to create under the class hello world. And void indicates that this function returns nothing, it returns void. And system.out.println, we will be using it to display some string on the screen, so on the console. So here the string must be enclosed within double quotes in Java. So how to execute this program? Just we shall click on this run hello world.java in Eclipse, and then the respective output will be obtained, that is a hello world. So in this demonstration, we have given you the idea that how to create a Java project, Java package, Java class, how to type code in Eclipse in that particular Java class, whatever you have created. Here it is hello world, and how to execute the code to get the output in the console. Thanks for watching this video.
In this video, we are discussing arithmetic operators available in Java.
In this demonstration, we are going to discuss different arithmetic operators whatever available in our Java code. We have defined three variables of type integer, and here we have defined one scanner class object. This scanner class object, using it we shall take inputs from the keyboard, and then we are going to perform addition, subtraction, multiplication, division and other arithmetic operations using Java arithmetic operators. So scanner is equal to new scanner. So this is a new scanner is a constructor we are calling, so that we can instantiate this scanner object. and system.in, it is depicting that from the system's default input device, that is our keyboard, will be getting stream of characters. And then we are taking this input from the keyboard and also we are converting it to the respective integer using this method next int, and that will be assigned to a at first, and next time I'm calling scanner.nextInt method, it is assigning the input integer value to b variable. And now we are doing this addition. The addition operator is plus, subtraction operator is minus, there is a multiplication operator star, there is a arithmetic division operation, that is our slash font slash. Here we are having the remainder operation to get, there is a modulus, we are getting this one as percentage, and in this way whatever the results we are getting, and they are getting printed accordingly. So in this way, and at the end of the code we are just closing the scanner object. So we are going to use different arithmetic operators in this demonstration. So let me execute my code here. So enter the value of a and b, that means this line is getting executed. So now it is asking to input two values, and first value will be assigned to a and the second value will be assigned to b. Let us suppose I'm putting the value say 100 and say 12. In that case, what we are getting after addition, it is 112, it's perfectly okay. Subtraction 88. After multiplication means we are doing this one using this star, that is a multiplication here we are having, so that is 1200. Here we are doing this division operation, this arithmetic division using this slash font slash. A and b both are of the type of integer, so the quotient will be also of the type of integer. Result has been defined as integer type of variable, so we are not going to get any fractional part here, so we are getting 8, and then remainder, that means 100 by 12, that means 100% 12 here to get the remainder, and as a remainder we are getting here 4. So in this demonstration we have explained that what are the different arithmetic operators in Java available and how to use them in our Java code.
Here in this video, we are discussing unary operators in Java.
In this demonstration, we are discussing unary operators. We have defined two variables var1 and var2 of type integer. var1 is equal to 50. So assigning 50 to the variable var1, and var2 is equal to minus of var1. That means here we are using this unary minus. Unary means this particular operator is requiring only one operand to operate it on. If I write minus 10, here minus is requiring only one operand, that is 10. But if I write 10 minus 5, here minus operator is requiring two operands, 10 and 5. In that case the operator will be known as the binary operator because it is requiring two operands. But if you write only minus 10, then the minus is actually working as one unary operator. So minus unary operator to invert the sign of the value of var1, and now we are printing the value of var1 and var2 both. So if I go on executing, I can find that one. This var1 is still with this 50. The var1 is still with this 50, but var2 has got the value minus 50 here. Next one is that var1 is equal to 50 and var2 is equal to var1 plus plus. That means you can find that this plus plus operator is nothing but one unary operator. It is requiring only one operand, that is a var1, and here we are doing the post increment. That means at first it will store the value, then the value of var1 will get incremented. So store previous value, then increase var1 by 1. So we have written everything in our comment. So var2 is equal to var1 plus plus. So as a result of that, you can easily find that the var2 has got the value 50 and var1 after doing this increment has got the value 51, because the previous value of var1 will be assigned to var2, and that is 50, and then var1 will get incremented by 1. So var1 itself will have the value 51 here. So that is happening in this particular output line. Next one is that we are doing the same, but here we have written this one as plus plus var1. That means pre-incrementing, increasing var1 by 1 and then assigning it to var2. So from the 50, if I increase the value of var1 by 1, so it will become 51, and then 51 will be assigned to var2. So we are expecting that both var1 and var2 will be printed as 51 and 51. So there is a respective output line. So next one is that where assign var1 is equal to 50, and similarly we have done the post decrementing, that means store the previous value and then decrease var by var1. So in this way it is going to do that one. So I'm just let me explain it here. So var1 is having the value 50, so 50 will be assigned to var2 and then var1 will become 49 here. So as a result of that, you can easily find that here we are having this 50 for var2 and then var1 has got decremented by 1, so it has become 49. So at first 50 will be assigned to var2 and then var1 will be decremented by 1, so it has become 49. Next one is our pre-decrementing. So pre-decrementing means that here we shall be decrementing the value of var1, so it will become 49 and then that 49 will be assigned to var2. So both var1 and var2 will have the value 49 and 49 respectively. Boolean bool1 comma result. So that means here we have defined two variables, bool1 and result. Bool1 is containing the value true. That is, the not of bool1 will be assigned to result. So as a result of that, if you print bool1, it will print true, and if you print result res, then it will print not of true, that is false. So let us go for the execution. You can find that the bool1 is true and result is false. So in this way, in this demonstration, we have given you the idea that how these unary operators can be operated in our Java code.
Bitwise operators in Java.
Here in this demonstration, we are discussing bitwise operators available in Java. So we have defined two variables, val1 and val2, with the values 12 and 10, and they are of the type of byte. So the binary representation of 12 in byte, that means in 8 bits we have written, and also the binary representation of 10 in 8 bits, we have mentioned that one. So byte result, so we are defining another variable result here. So it has been represented as res. So result is equal to byte of not val1, that is a bitwise complement val1. So this is known as the not. Also the operator is known as tilde operator, and we are converting it to the byte type and assigning to this result. Now what is happening here? So this val1 is actually containing 12, that means there is a binary representation of 12. So 12 means 8 plus 4, that means at the 8 and 4 place we'll be having 1 and rest bits will be filled up with zeros. So now to get that ones complement of it, we are getting this one as 4 times 1 and then 0011. So that is the not of val1. So if I print this one, we are getting here minus 13. Now question is coming in mind, why it is minus 13? Why the value has got printed as minus 13? We know that when the first bit is 1, then the number will be treated as a negative quantity, and to get the magnitude I should calculate its 2's complement. So 2's complement means 1's complement, that means zeros will be replaced by 1 and 1's will be replaced by 0 plus 1, and that is the 1's complement plus 1 will be the 2's complement, which will be denoting the magnitude part of the number, and the first bit will be denoting the sign, that is our negative, because the first bit is 1. So now what is this? This is our 12 plus 1, so that is a 13. So minus 13 will be the outcome, and that we are getting here as the outcome here. Next one is val1 and val2. So and here we are doing the bitwise AND operator, so it will be denoted by this ampersand. So now if we do the bitwise, thus you can do for the columnar, just see. So here only we are having this 1 and 1. So that's why this place will produce 1 here, and rest all places will be producing 0. So this 1 means at the 8th place we are having 1. So if we print, we can find that after doing this ANDing, we are getting the 8 as the outcome. In case of OR, what is happening? If you go on ORing, bitwise if you go on ORing, you can find that it is 1 or 1 is 1, 1 or 0 is 1, 0 or 1 is 1, and the rest of the bits will be 0. So 1, 1, 1, 0 will be the outcome. So that means 8 plus 4, 12 plus 2, that is the 14 here. So that's why after ORing, we're getting this one as 14. Next, we're going for this XOR operation. In case of XOR, it will be denoted by this upper caret, that is the operator, that is the XOR operation, bitwise XOR operation. So what will be the outcome? You know that in case of XOR operations, similar bits will produce the output 0, and dissimilar bits will produce the output 1. So here I'll be getting 1, because 1 and 0 XOR is 1, and this 1 XOR 0. So 0 XOR 1 is 1. So rest of the bits will be producing 0 after XORing, bitwise XORing. So 1, 1, 0 will be the outcome. So I am expecting 6 as the result. Yes, we are getting 6 after doing the XORing. Next one is there is a shift 2 bits towards the left, that is a val1. So here we are having this val1, so I'm just shifting it towards the left for 2 bits place. So I'm just going for, so if I go for this 2-bit place, so it will be coming like this, that is towards the left. So these 2 bits will be off, will be lost, and 2 new bits will be coming to fill up the blank space. So we can find that it will be having the format like this, and which is nothing but, here it is nothing but 32 plus 16, and that should be 48. So we are expecting that the value will become 48 here. So now let me go for the execution. You can find that the value has become 48. Actually what is happening, the bit which is at the 8th place with the place value 8 has been transferred to the place value 32. The bit which was at the place value 4 has been transferred to the place value 16. So actually we are doing 2 to the power of 2 multiplication. Actually we are doing 4 multiplication, that means 2 to the power of 2 multiplication. What is 2 to the power of 2? This 2 is actually denoting that for how many bits we are shifting towards the left. That means if you shift towards the left for n number of bits, then the magnitude will get increased by the factor of 2 to the power of n. So that's why 12 into 2 to the power of 2, that means 12 into 4, so 48 will be the outcome. So that's why we are getting here 48 as outcome. Next one is that we are going for this val1, which will be shifted towards the right and 2 bits towards the right. Then what will happen? So these 2 bits will be lost and extra 2 zeros will be coming up. So these 2 bits will produce 2 and 1. So that means I'm going to get here 3. So that's why we're getting the outcome as 3. So what is happening if we go for n bit right shift, then actually the number will be divided by 2 to the power of n. So here the value of n is equal to 2 because we are doing 2-bit shift. So 2 to the power of 2 is 4. So 12 by 4. So 3 will be the result here. So in this way we have explained the bitwise operators which are available in Java with proper demonstration and example.
Relational operators in Java.
Here in this demonstration we will be discussing on relational operators available in Java. We have defined one variable of the type boolean. The name of the variable is result, and the first relational operator we are using, that is equal to. So 10 equal to 10, it is a condition, so it will return either true or false depending upon the condition is true or the condition is false. So true when a left operand is exactly equal to the right operand. So that will be assigned to the result. The value of the result will be printed. So we can see that the result is true here. Next time we have gone for 5 less than 5. So here this less than is nothing but one relational operator in Java. So that will be assigned to result. 5 is less than 5 is false. So true when the left operand is less than the right operand, but that is not happening here. Here both the operands are same. So that's why the result will get printed as false. So you can find that the result has got printed as false. Next one is result is equal to 5 less than equal to 5. Here less than equal to is one of the relational operators in Java. True when left operand is less or equal to the right operand. So we are printing the result and it is getting printed as true here. Next time you are using the greater than, that is a 10 greater than 5. So this greater than is one relational operator, true when the left operand is greater than the right operand. So now here the result is getting printed and you are finding that the result is getting printed as true. So we are getting this outcome here. Next one is greater than equal to. So 10 greater than equal to 5. So this condition is true. So result will be printed as true here. So the another relational operator, that is a not equal to. So 2 not equal to 2. True left operand and the right operand are not the same, but they are same here. So that's why the result will be assigned with the false and the result will get printed. So I'm getting the outcome as result is false. So in this way we have discussed different relational operators available in Java.
In this video we are discussing conditional operators in Java.
We are discussing how to use the conditional operators in Java. So here we have defined 2 boolean variables, that is the bool1 and bool2, and another variable that is our result, res. Bool1 has got initialize with true and bool2 has got initialize with false. So result is equal to bool1 or bool2. You can find that here we have used double filter sign. So true when at least one of the value, if it is true, then the outcome will be true, and that is the basic logic of OR. And in this case, this result is equal to bool1 and bool2. So that is our double ampersand, which is another conditional operator. So true when both values are true here. So here we are expecting that result will be printed as true because one of the values is true here, bool1 is true. But here we are expecting that the result will be printed as false because here this bool1 is true but the bool2 is false. So now let me go for the execution. You can find that it is true and it is false and it is according to our logic. So now let me make it true here. Then what will happen? In the both cases, for this double filter, that is a and this is a double ampersand, that is our double filter is OR and double ampersand is our AND. In the both cases, in the both conditional operators will produce the outcome as true. So let me go for the execution. You can find that they are producing the outcome as true here. So in this way, in this demonstration with the proper example, we have given you the idea that how to use the conditional operators in our Java coding.
In this video, we are discussing input-output techniques in Java.
In this demonstration, we are discussing input and output in Java. So that is one message, that is this is an output line. This message, this particular string is going to get printed using system.out.println. Now what is system? System is nothing but one class which is defined under the package java.lang.system. That means the package name is java.lang and the class name is system. So let us go for exploration of this. So this is our input output Java program, and here you can find that we'll be going for this java.lang. You can easily find java.lang is there. So you shall go for rt.jar and then you shall go for java.lang. So different packages are given here. So let us go for java.lang. So they are arranged in the alphabetical order. So I shall go for this java and then lang. So that is my java.lang. Under this java.lang, we'll be going for the class that is our system. So if you go for the class system, they are also arranged in the alphabetical order. So that is our system class. So this is our system class has got opened. So now you see here we are having system.out. Now what is out? And this out is nothing but one printstream class object. And this printstream class object is there, and this particular object must be of the static scope, and it is written here also. There is a public static final printstream out. So this is a declaration, that is out is nothing but one instance variable under the class system, and this instance variable is nothing but one object of the class printstream. As this particular object is having the static declaration, so as a result of that we can access this object directly from the class name dot operator. So let us go for this out. So now we are going for the system. You can find that here we are having this out here. We are having this out here declared. There is a public static final java.io print stream class object out is there. As this out is having the respective static declaration, so this out can be accessed directly from system.class, system class.out here. So now this is our java.io.printstream. So let us go for java.io.printstream to check that this particular java.io.printstream class, where the java.io is the package name, printstream is the class, must be having a method that is our println. So that's why we can access it. So we are going for this java.io. So that is our java.io. We are going for that. So this is our java.io, and from here we'll be going for the print stream. So there is a class called print stream. This is a respective class, and this particular class is having a method that is a println, and this method is not static. So that's why I cannot be calling this method println directly from printstream.println, because the method is not static here. So that's why I should declare one object under the printstream class, then object name.println can take place. So that's why this system is having our out is the object of this print stream class, so out.println is allowed here. So that's why we're getting the respective help here also. We're having this java.lang.system, and this is the out. This out we're having, and this out is nothing but one print stream class. This print stream class object, that is we're having this one as java.lang.system.out, and it is declared under the static scope. So that's why we can directly access this out from this system.out, and println is nothing but one method. This method is having the prototype, that is a void. It returns void. It is defined under the package java.io, and it is having the respective class, that is a print stream, and .println is a respective method, and it takes a string as input argument, string object, and there is a string object we have passed. So in this way the code is actually getting executed. So I have given you the explanation of the system.out.println, which is a very common question in the interview or in the exam viva. So if I go for the execution, you can find that this is an output line. This string has got printed here. Okay, so this string has got printed. Next one, we are having this particular x is equal to 10. X is of the type integer. So value of x, we are doing this one as concatenation. So string concatenation integer. So ultimately it will be converted implicitly to the string, and that's why the output is coming as the value of x colon 10 here. Next one is that we are not using print ln, we are using print and print. So what is happening? The first string and the second string, these things have got printed in the same line. But if you put here ln here, if you put here ln, then obviously these two lines will get printed in two separate rows. So there is a first string, there is a second string. So if you make this ln omitted, you can find that the second string, this string is getting printed in the same line in which the first string got printed. Next one is that system.out.printf. This is the value of x, pi is equal to this. In this way we can go on printing. So x will have this particular formatting, that is a decimal type, and this is nothing but 22f, means 22 will be treated as a float number by 7, so it will be printed as %f. So we can find that it is getting printed as 10 and 3.142857. So in this way we have explained that how this outcome is coming. Now scanner class object. So this is a scanner class object. So this is a scanner class we are having. So it is under the java.util.scanner. So java.util is the package name, scanner is the class name. Under this class we have defined one object. This object has got instantiated, is getting instantiated using this constructor. So new, and then the constructor name, which is must be same as the class name. Here the class name is scanner, so the constructor name is also, the method is also known as the, will be called by the scanner. And there is a system.in, there is a scanner class object to read from the input device, and here the stream of characters will be coming from the system's default input device, that is our keyboard here. So system.out.println enter data using keyboard. So when the data will be entered, so that can be accessed using scanner.nextInt. You see here the input will be converted to the integer, and that will be assigned to int data, and later the data is getting printed here. And scanner.close, so close the scanner object when the inputs are obtained. So let us go for the execution. You can find that it is asking for some input. I'm giving the input as 100. Now you can find that the data that has been read is 100 here. So in this way, in this particular demonstration, we have discussed that what are the different inputs and output, how we can do the inputs and outputs in our Java coding, and we have given you the detailed description what is system.out.println.
Strings in Java.
In this demonstration, we are going to discuss how to use string in our Java code. At first, we have defined one character array. This character array is containing these 6 characters, and this is known as a character array, and name of the character array is character string. We have defined one scanner class object as usual. We did that one before also, and we have defined one string class object str. is equal to new string. You see in the constructor, string is nothing but a constructor here, this string method, and which is taking this character array as input argument. That means from this character array it will create a string and that will be assigned to str. So using the constructor, passing this character array as input argument to the constructor name here the string function, and this constructor, from this particular constructor, from this character string character array, we are generating a string and that will be assigned to the variable string object str. So see system.out.println, we are printing the value of str, and now we are going for this. So system.out.println, enter a string. So using the scanner class object scanner, using the method that is our next, we are taking one input, one string as input, and that will be returned and that will be assigned to the string object str, and then the str is getting printed. So here we are showing you that how to take the user given input, user given string as input, and how to assign that one to a string class object. Here this str is getting assigned with this particular string. So there is a Java string, so direct assignment we are doing. So direct assign string to the string type object str. Next we are printing the value of this str object. Then we are going for the string concatenation. Concatenation means adding two strings. So here we are adding three strings. One is a string, next one is this blank, and next one another string, that is concatenate. Here plus operator is being used as the string concatenation operator. So ultimately this concatenated string is getting printed and we are closing this scanner class object. So let us go for the execution. You can find that the value of str is string, that means from this character array which is having these 6 characters, we have generated one string and that has been assigned to this str, and here this string constructor is being used, and this string is a class which is defined under this java.lang package, and it is taking one character array as input and generating one string as output, and that will be assigned to this str, and that has got printed. Now it is asking for the string for input. So I'm going for this hello, and then pressing enter. So the value of str is hello. So now it has taken the input from the keyboard. Next is a function which is accepting a string input and it is returning the string as output, and that will be assigned to this str. Str has got printed, so hello has got printed. Now here we are going for the direct assignment of a Java string onto the string object str, and the str has got printed. Now here we have done the concatenation of 3 strings. So here this plus is actually working as a string concatenation operator. So string blank space concatenate, these 3 strings has got added and has been assigned to the string class object, that is str, and str has got printed. So in this demonstration we have given you the idea that how to define one string object, how to initialize one string object directly or taking some inputs from the keyboard or using constructor, and what is string concatenation.
String functions in Java.
In this demonstration we shall discuss how to use different inbuilt library string functions in our Java code and what are their purposes. Here we have defined 2 string objects, that is str1 initialized with this hello and str2 also initialized with this hello. Here all the letters are in capital. Here's the first letter is in capital and rest of the letters are in lowercase. So the first function we are using, that is the str1.length. So str1.length is a function which is defined under the string class. There is a public int length, and it denotes that it returns one integer and it is under the public scope. So from the objects, from the string class objects, we can easily access this length function using the dot membership operator. So here see, if you go for the execution, we are getting this length as 5 because hello is having 5 number of characters in it, so its length will be 5 here. Next, str1 dot equals str2. Here both are hello string, but they are not having the same case for all the letters. So that's why str1 dot equals. Now what is equals? So equal is nothing but one method which returns a boolean under the public scope, and the name of the method is equals, which takes object as input argument. You can easily find this one here in the declaration. So now str1 dot equals str2. Now what is the outcome here? We can easily find that hello and hello are not same. That means the control is coming to this else part, because these two strings are not equal, because they are having different uppercase and lowercase characters here. So but if you go for another method, that is the equals ignore case. So equal ignore case will be working as the same as equals, but here only the case sensitivity will be ignored in case of equals ignore case function. So it returns one boolean and it takes the string, that is another string, as input argument. So now if we go for str1 dot equals ignore case str2, so it is giving me the output that hello and hello are same, ignoring case. So this is the outcome we are going to get. So this particular statement is getting executed. That means it is going for the then part and else part is remaining unexecuted. Next one, system.out.println, the character at the position number 2 is str1 dot caret 2. So what is a caret? Caret is nothing but one function, that is a public char caret int index. So it returns one character which will be placed at the index position number. Now here we are operating on this str1. We are calling this caret from this str1 string object. So first character will be at the place at the index number 0. So it will be at the index number 0. It will be at the index number 1. So L will be at the index number 2 here. So if I go for the output, we can find that the character at the position 2 is capital L. So that is coming from this L. This L has been retrieved here. Next one, we're going for system.out.println comparing str1 and str2 distance, that is str1 dot compared to str2. So now here you can find that this H and this H are having the same ASCII code, but this E, capital E and the small e will have the ASCII code difference of 32. We know that capital A is having the ASCII code 65 and the small a is having the ASCII code 97. So always the same character in the lowercase and in the uppercase will have the ASCII code difference of 32. So uppercase characters will have the ASCII code 32 lesser than the same lowercase character. So here we are doing this one as capital H ASCII code minus capital H ASCII code. The value is 0. So for the non-zero difference it will return, for the 0 difference it will go on continuing. So the next one, this E ASCII code and this small e ASCII code, the difference value will be minus 32. So as a result of that, we are getting the outcome as minus 32 here, because we know that capital letters ASCII code will be 32 lesser compared to the same letter in the lowercase and its respective ASCII code if we consider. So now we are going to have this str1 and str2 initialized with the strings. You know, the str1 and str2, they have got initialized with the strings. Now for the rest of the operations, we'll be considering them. So here we are having str1 dot starts with AAB. So str1 really it is starting with the string AAB. So now what is the starts with? So starts with is nothing but one function which returns boolean under the public scope. You can easily find, and it will take a string as input argument. So this particular string is nothing but a prefix. So here this AAB is really the substring with the help of which str1 has started. But str1 dot ends with ACA. Really it is not ending with this ACA. So here it will be returning the boolean value, and that will be false here. You can find that public boolean ends with string suffix, and here it is returning, we are expecting it to return true here. So let me go for the outcome. You can easily find. So here we are getting this one as true, and here we are getting this one as false, as we have explained earlier. Next one is this one. That means first index of BB in str1 is str1 dot index of BB. You can find that BB is occurring in multiple places in str1, but it will consider the first occurrence of BB. So it is starting from the index number 2 here, because it is 0, index 1 and index 2. So it will be starting from the index number 2. So this is my index of, which is nothing but a function public int index of string str. So there is an integer it will return, that is it will return the index. So let me show you that what is the outcome we are getting. So here we are getting this one as 2, as we expected. Next one is last index of. In case of last index of, we will be searching for BB and the last index will be returned. So now just consider this one as index 0, 1, 2, 3, 4, 5, 6. So from the sixth index BB will be found. So we are getting this outcome as from the sixth place. So this part we have covered till now. Next one, we are going for this replacing ABB to XY of str1 is. So str1 to replace ABB XY. It is one point to be noted that the string which is going to be replaced is having the length 3 and which will be replacing will be having the length 2. That means these two strings may or may not have the same length here. So you can find that ABB will be obtained here. So that will be replaced by this XY and this ABB will be obtained here. So that will be replaced by this XY. So now let us go for the outcome. We can find this one as AXY, CXY and then we are getting this one as AA. So AXY, CXY, AA. So that is the string after getting replaced. Next one is that str2 substring 5, 11. You can find this one as we're having this particular substring and it is public string substring int begin index, int end index, returns a string that is a substring of the main string. The substring begins at the specified location, that is a specific index, that is the begin index, and extends to the character at the index in the end index -1. So that is very important. That means this 5 will be inclusive but this 11 will be exclusive. That means it will pick up characters starting from the index 5 to the index 11 minus 1, that is 10. So let me work on that. So for this str2, so index number 0, 1, 2, 3, 4. So it is starting from the index number 5. So 5, 6, 7, 8, 9, 10. So it will return string whatever we have calculated. So let us go for the checking. So you can find that it is returning the string. So that is the outcome we expected here. Now let us go for the next part of our code. So here we are having we have covered this substring. Now we are going for this split. So this is a test string. str1 is containing that one. So now string array, split array. So split array is the name of the array, which is a string array. And here str1 dot split. This split is actually taking one regular expression as input argument. So it is taking the delimiter with the help of which the string will get splitted. Here the delimiter has been selected as this hyphen here, because the string is containing hyphen for multiple number of times, and the split function returns one string array. So this here the array name is split arr. So now using the for each loop, we are going for string sp colon split arr. We are going to print this value of sp. So for each and every iteration, it will pick up one substring and that string will go on printing. So you can find this one as this is a test string. So this is the respective substring they have picked up. The string has got splitted into and the outcome will be has been kept in the string array. And now using the for each loop, we are picking up each and every string from the string array and printing that one accordingly. Now this is my string, which is str2, where we are having lots of blank spaces are there, lots of blank spaces prepended and appended here. So if we print this str2, the outcome will be like this. You can find that this str2 has got printed. So before doing the trim operation, you can find that so many blank spaces beforehand and so many blank spaces afterhand. But if you go for str2.trim, you can find that these two brackets are coming very packed, very tight here. That means all the redundant blank spaces, leading and trailing, they have got truncated out, they have got discarded here. So let me do one experiment. If I put multiple blank spaces within the string itself, not only the leading and trailing, but multiple blank spaces within the string itself, then what will be the outcome? You see, the trim is doing nothing with the blank spaces, multiple consecutive blank spaces within the string. So that is not getting discarded. They are remaining the same, but all the leading and trailing blank characters will be discarded, will be truncated out using the method that is a trim. So if you put my mouse pointer on this trim, we are finding this one as public string trim. So trim is nothing but a function defined under the string class, and it returns the trimmed string as outcome. as the output. So in this way we have used multiple different inbuilt functions in our string class in our sample program.
String buffer and string builder in Java.
In this demonstration, we are going to discuss string buffer and string builder class objects. At first, we are dealing with the string buffer. So here you can find that one string buffer object, class object has been defined, that is sBuffer, which has been instantiated with this constructor here. And the default capacity of this sBuffer will be 16 here. So let us go for the execution. You can find that when you are printing this sBuffer.capacity, we are getting here 16. This sBuffer is now instantiated with the string buffer constructor, and here we are setting the capacity directly as 50 here. As a result of that, when you are setting that one, so it is having the capacity 50. So now again we are defining this sBuffer with this string buffer constructor, and here we are passing one string as input argument. Then what will happen? The 16 plus the length of the string will be the total buffer capacity. What is the length of the string? If you go on counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 characters are there plus 16. So you are expecting the capacity would become 31 here. And here we are printing the sBuffer directly. So sBuffer has got printed, that is my string buffer. Next, we are dealing with the string builder objects. So string builder sBuilder is equal to new string builder my string builder. So this is a string which will initialize this sBuilder. So if you print this sBuilder now, this object, if you print, then it is printing my string builder. Next one is that with this sBuffer we are appending a new string. With this sBuffer we are appending a new string here. So and also with this sBuilder object we are appending another new string. So here we are mentioning one method. That method is known as the append, which is public return string buffer object, and then its name of the method is append, and it takes a string class object as input argument. Everything has been mentioned here. So now after doing this append operation, then what is the net outcome? You can find that the pre-existing content is surviving. The pre-existing content is up to this part, and the new content has got appended at the end, and similar thing has taken place in case of string builder class objects also. Next, we are initializing this sBuffer and sBuilder with a new string. So there is one string, that is another string. So sBuffer.insert 5 PQRST. So what is the outcome here? You can find that it is producing the outcome, that is AABCA, then PQRST, then BBC. Why it is so? Because 0, 1, 2, 3, 4. So after this fourth, the fifth position, at the fifth position this PQRST will get inserted, and then BBC will be there at the end. You can find that we are having the same thing. So 0, 1, 2, 3, 4. Then at the fifth place PQRST has got inserted, and the remaining part of this sBuffer is there. Next, in case of string builder, if you do the insertion here, that is at the third place we are inserting X, Y, Z. So what is happening in this case? So 0, 1, 2, then at the third place X, Y, Z has got inserted, and the remaining part of this sBuffer is still there. Next, we are going for the reverse. So sBuffer.reverse and sBuilder.reverse. So this particular reverse method will actually reverse the content of this string builder and string buffer objects. So you can find that the reverse is obtaining has been printed, and reverse of this current content has got printed here. So in this demonstration we have discussed how to deal with the string buffer and string builder class objects, and what are the different necessary methods or whatever we can use in our coding for storing our string in a certain better way.
In this video, we are going to discuss static keyword in Java.
In this demonstration, we shall discuss the keyword static in our Java programming. Now, what is the static keyword? So here we are having one class. The name of the class is static demo, and it is having int static var. So there is one variable, and this variable is of type static. And this is another variable which is a non-static, that is int var. So static variable we have defined as static var of type int, and non-static variable we have defined as var of the type int. So this is the constructor which will initialize the non-static variable var, which will be equal to 0. Next one. Here we have defined another static method. Here we have defined one static variable. Here we have defined the static method. So public static void set static var int x, and this x will be assigned to this static var, that is a static variable. So always remember, in case of static method, they can access only the static variables. Non-static variables cannot be accessed from here. So if I want to write this one as a var, say is equal to 100, if I write here, so it is having one error message is coming, and that error message is telling that cannot make a static reference to the non-static field var. So that is the error message we are getting, because non-static method cannot access static method cannot access non-static variables. So that is very important. Next method is known as the increase. This method will increase the value of the static var by 1, and also value of the non-static var, that is var, as 1. So in this way, two variables have got increased here. So we have got one lesson that static method can access only the static variables, but non-static method can access both the static and non-static variables. Next one is the display, which will print the current value of static var and the current value of var as well. So now here we are defining the class, that is the keyword static, which name is same as that of the file name here. So under this particular keyword static, we are defining the main function. We are defining two demostatic objects, that is the st1 and st2. They are defined under the class demostatic and instantiated with the constructor and the new keyword. So here we are having this st1 dot increase, st1 dot increase. So 2 times the static variable will be increased here. Always remember, so irrespective of the number of objects we are going to define under the class here is static demo, only one instance of the static variable will be defined here. So only one instance of the static variable. So this static var will be defined once only, irrespective of the number of objects we are going to define under this class, that is the static demo. As a result of that, st1, when it is increasing the static var by 1, then same increase function will be called from the st2, it will be also increasing the same static var by 1. But as the var is a non-static variable, so it will have a 2 separate instance with respect to st1 and sp2 separately. So as a result of that, when we are calling this st1 dot increase, the var which is getting increased 2 times, because we have called this this function increase twice. So this instance will be totally different from this st2 dot var. When we are calling this increase for 3 times, so another new instance of var will remain created against this st2 object, and that will get increased for 3 times. So I think now the conception will be cleared if I go for the execution. So the value of the static variable is 2 and value of the non-static variable is 2 here, because here we have called this st1 dot increase 2 times. So the static and the non-static, both the variables have got increased by 1 and 1, and initially their values were 0 here, because we have initialized this one as 0, and automatically the static var will be instantiated with the value 0, will be initialized with the value 0 initially. So st1 dot display is displaying that both the variables are having a value 2 and 2. Now from this st2, this increase function has got called thrice. So the static variable will get increased starting from 2. So 2 to 3, 3 to 4 and 4 to 5. But this var will be having a separate instance for the new object st2. So it will be increased from 0 to 1, 1 to 2 and 2 to 3. As a result of that, when we are going for st2 dot display, we are finding that the static variable is having the value 5 and the non-static variable var is having the value 3 here. Here we are having the set static var. So here we are putting this 50, and 50 will be assigned to this static var variable. So if I print this particular variable, we can have this one as 50. You can find that we are having this one as 50. So this particular method, static method, has been accessed from the class name directly. From the class name directly it can be accessed, and this static variable can be accessed from the class name. Now if I use this one as st1, if I use this one as st1 and also here as st1, you can find that they are executable, and we are getting this same output here. Static variable without object is 50. So now if I call it from the st2 also, they are accessible because they are static. So irrespective of the number of objects we are defining under the class, the static demo, these two static members, variables and methods, will have a single instance in the computer's memory, and they can be accessed either using object name dot or using class name dot directly. So in this way we have shown you that what is the static, how to use the static keyword in our Java code.
In this video, we are discussing class and objects in Java.
In this demonstration, we shall discuss class and object in Java. So here the name of the class is student, and this particular class is having three member variables of the student class, and their string name, int id, and string measure. So as here we haven't mentioned them that they are under a private scope or public scope, that means they are in the default scope. So here we are having one method. The name of the method is setName. From the name of the method, it is quite obvious that it will take one string as input, and which will set the name instance variable here. And similarly for set measure, it takes a string as input argument, and it initializes the measure instance variable. And the display method is actually printing the name, id, and the measure, and in this way all the three instance variable contents will get printed using this display method. So here the name of the program is class object.java. You can find that this particular class is having class object.java. You can easily find that in the same Java source code we have declared two classes. One is the class student, and another one is the class object. So what will happen if we define multiple classes in the same Java program, in the same Java source code, then one of the classes will be of the type will be under the scope public, and main function will be defined in one of the classes only. So this public static void main string array args, and here we have defined two objects under the student class, and those two objects have got instantiated, memory spaces have got allocated, and they have got instantiated by using new student class constructor. Now we are using the set name, we are using the set measure to initialize the name and the measure instance variables, and directly we are writing s1.id is equal to 1021 to instantiate or to initialize this id instance variable. So similarly we have done the same for the s2. S2 is another object under the class student, and which has got instantiated using the constructor of the student class. And now we are going for the s1.display and s2.display methods. So let us go for the output. So the student name Joy has been printed, the student ID 1021, and major subject here computer science, and in this case the name and the ID and the subject has got printed, and they have got printed after calling the method s1.display method and s2.display method. So in this way we have discussed that how the Java, in case of Java, how we can define one class, and then how to define objects under the class and access class members.
In this video, we are discussing Boolean type data in Java.
In the demonstration, we are going to discuss Boolean type of variable, that is the mybool. So Boolean mybool. So mybool is a variable of the type Boolean. Mybool has got initialized with a value that is true. Here you can find that in case of true, all the letters are written in the lowercase. And then we are trying to print the value of mybool there. And mybool is equal to false. We are setting the value of mybool with false. That is, we know that Boolean data type can have two values, either true or false, and then it is printing there's mybool there. So let me go for the execution. You can find for the first time mybool has got printed as true. For the second time mybool has got printed as false. So now let me go for some other experiments. Here I'm writing here 100. So now if I go on printing, I'm finding that it is producing error because proceed. You can find that it is producing error because this my bool cannot hold any other data types value. It can hold only true and false as it is showing the respective error message. So the error message is showing that exception in thread main java.lang.error, unresolved compilation problem, type mismatch, cannot convert to int or boolean. From int to boolean, because 100 was int, it cannot be converted to boolean, and that's why it is producing one error at the line number 13 here for this respective Java code. So that's why you can find that this particular boolean variable can hold only the value true and false, cannot hold the value of any other data types data. So that's why in this demonstration we have given you the idea how to deal with the boolean type of variable. Thanks for watching this video.
In this video, we are discussing character type of data in our Java coding.
In this demonstration, we are going to deal with the character type of variables. We have defined one character type variable, that is a mychar. And this mychar has got initialized with this capital A enclosed within single quotes. That means the direct assigned character capital A, which will be enclosed within single quote. And in our Java programming, whenever you are trying to deal with the characters are to be enclosed within single quotes here. So system.out.println, the value of mychar I have printed here, and so the effective outcome is capital A. Next one, this mychar has got initialized with this 70. What is the 70? 70 is the ASCII value of character F. 70 is the ASCII value of character F, because we know that capital A is having the ASCII code 65, so F will have the ASCII code, that is our 70. So after assigning this 70 to this mychar, if I go on printing this mychar, remember mychar was defined as of the type char, so that's why whenever you are going to print this mychar, it is printing capital F, not 70, because it is a character type of variable. Here in this case, the mychar has been initialized with /u0041. There is a Unicode hexadecimal value for integer, and this value will be ranging from 0000H to FFFFH. Here H stands for hexadecimal. So as a result of that, when we are assigning /u, that means the Unicode hexadecimal format 0041. So 41, if we want to convert this 41 to the decimal equivalent, it is 4 into 16 to the power of 1, that is 64, plus 1 into 16 to the power of 0, that is 1. So 64 plus 1, that is 65. That is the ASCII code of capital A. So if I go on printing this mychar, you can find that mychar is printing capital A here. So in this way, we have shown you that how to deal with the character type of variables in our Java code. Thanks for watching this video.
This keyword in Java.
In this program, we shall discuss about the keyword this. So here we have defined one class. The name of the class is my class, having private int a comma b, two instance variable. So public my class, so that is a constructor which is parameterized constructor having int a and b as input parameters. Now the thing is that these input parameters a and b, and also the instance variables are a and b. So if we want to initialize this a with this input parameter a, then that may produce some ambiguity if you write a is equal to a. So that is ambiguous. So that's why it is better to write this dot a is equal to a. Here this is actually indicating the object which will be defined under the class my class. So that object name dot a, in this way I'm accessing the instance variable a is equal to a, and this a which is on the right hand side of this assignment statement is nothing but the input parameter a. Similarly, this dot b is equal to b here. This is my non-parameterized constructor. The constructor name will be same as that of the class name, that is a my class. Here also it is my class, and it is non-parameterized, and here we are calling the these 0, 0. That means it will call the parameterized constructor with the value 0 and 0 as two parameters. So in this way, this is actually referring the constructor, that is the parameterized constructor, because we are passing this 0, 0 as the parameters. We are having the set data, and it is having this a and b as input parameters, and this dot a is equal to a and this dot b is equal to b, That means the object defined under the class my class, that object name dot a is equal to input parameter a, and object name dot b will be equal to input parameter b here. Display is actually displaying the value of a and b respectively. Now here we are having this keyword, this the class we are defining containing the main function. The my class is having the object, that is the my object is equal to new my class. So the new is the operator, and this my class is actually the constructor with the help of which this my object has got defined. And now we are going for my object dot display. So display will print this a and b. We know that whenever you are calling this constructor is non-parameterized. That means this particular constructor has been called. So it will pass this, it will call this parameters constructor with the value 0 and 0. So what will happen, this a and b will be initialized with the value 0 and 0. So this my object dot display will print the value of a and b as 0 and 0. Next time we are calling this, that is a my object dot set data 23, 46. So set data will initialize this a and b with the respective values, and then my object dot display will print this 23 and 46 as the result, as outcome. So in this way we have discussed that how this constructor can be defined and what are the different types of constructors are there, and also we have shown you that how to use the keyword this, and this is actually referring the object defined under the class. So you can also call it as a dummy object name.
In this video, we are discussing user defined exceptions.
Let us go for a demonstration on user defined exceptions. Here we have defined one class. The name of the class is below age exception, which extends the exception class here. And there is a constructor, and this is a constructor of the class below age exception, and from this constructor it is calling the base class constructor. Here the base class is exception, and the base class constructor has been called using super, passing this argument string as input argument. So age is under 18. We have defined another class. The name of the class is application, where we are having this name, course and age. So 3 instance variables we are having. Application is the name of the constructor, which is taking this name and the course as input argument. So this name and course, the instance variables are getting initialized here. Age is also getting initialized with the default value of 18. This is non-parameterized constructor. Obviously the name of the constructor will be same as that of the class name. So the name of the constructor is application, which is non-parameterized, and from this non-parameterized constructor we are calling the parameterized constructor. So these null string comma null string. So here you can find that this is actually referring to this parameterized constructor, which takes 2 string objects as input argument, and here we are passing this to null strings here. So now we are having another method, that is the set age, which takes this age as input argument and which throws the below age exception, When this input age, the input argument age is less than 18, we are throwing this throw new below age exception. So you are throwing this below age exception class object. So we are throwing that one. So that's why this function is throwing below age exception. Otherwise this age, which is not less than 18, will be assigned to the instance variable age. So this dot age is equal to age. Now this is the display details, another method we are having, that is a member function. So here we are printing this name, the course, the age and so on. So now let us go for our class, that is the user defined exception. This is the main function here. We have defined 2 objects under the application class, 2 objects. One is application 1, another one is application 2. So this is our respective name. So we have passed this John and Java programming. So this name is nothing but this variable is this input parameter name will get initialized with that value, whatever is we are going to pass, and the course name will be initialized with this Java programming. So here this is my name and this is the course name we are having. So now application 1 dot display details. So the display details will be printed here. So now application 2 dot set age 17. You can find that here we have passed the age 17, which is below 18. So as a result of that, this set age, this particular method will throw below age exception. So that's why we have put this line under the try block, and try block is being followed by the catch block immediately. So below edge exception, E is the object of this below edge exception class, and within this catch block we are writing this E dot get message and E dot print stack trace. So now let me go for the execution of the same. So if I go on executing, you can find that the name of the student is John and applied for Java programming and taking the default age 18. So now in this case what is happening, so the application one.display details, it is printing accordingly. So in the next time when we are going for this set age method will be called from this application 2, that is the application class object, passing this input argument as 17. So as the 17 is less than 18, so it is throwing new below edge exception. So automatically the catch block will get the control, because this catch block is actually handling this below edge exception E, and the respective code is getting printed. So E dot get message is printing this age is under 18, and E dot print stack trace is printing the respective outcome. I'm going to show you the outcome here. So this is the outcome it is going to show. So you can find that the error has occurred at the line number 44. So you see at the line number 44 the error has occurred, and line number 24 is actually throwing this below edge exception. You can find that this line number 24 is here and 44 is here. So it is the respective line numbers are getting printed. So in this way, in this particular demonstration, we have discussed how we can define user defined exceptions.
In this video, we are going to discuss switch case statements in Java.
In this demonstration, we are discussing switch case statement in Java. So in this program, we have defined one scanner class object, and then we are asking user to enter a character. So scanner.next, this is a method next with the help of which we can take a string from the keyboard as input, and dot caret 0, it will take the first character of the string, and that will be assigned to the car character variable. So now we have taken input from the keyboard, and this is nothing but one character. And now switch character, depending upon the character value, we are having multiple cases are there. Case capital A, case capital B, case capital C, case capital D. Otherwise, the default case will be this one. So default will be coming always at the last of the switch case statement construct. So now if the case is A, that means if the character is equal to capital A, then this line is going to get printed, and break will terminate, will make the logic come out from this switch case construct, and the next line whatever is having in the code will get executed. So break will actually terminate and the execution of the switch case statement block, and it will come out, the control will come out from the switch case construct, and whatever the lines are written after this switch case, they are supposed to get executed next. So let us go for execution. I think that will clear up your conception. So now if I put here capital A, I'm getting, you have typed letter A, end of the program is getting executed at the end. If I go for another input, say if I go for say capital B, I'm getting this one. If I go for capital C, I'm getting this one. If I go for capital D, you can find that you have typed the letter D is going to get printed. You can find that end of the program is always getting executed, because the break is actually keep making the control come out from this switch case construct, and next part of the program is supposed to get executed. So now if I put any other value other than A, B, C, D, let us suppose I'm putting here R, then you have typed letter other than A, comma B, comma C and D. So in this way the default block is getting executed. So if you don't put this break, then what will happen? Say let us suppose I'm just omitting this break here. I'm just omitting this break. Then what will happen? If I put the value A, in that case you can find that you have typed the letter A and break is still there. So that's why the control will come out from this switch case, and then the next line is getting executed as well. But if I give the input say capital B, in that case, then what will happen? If I give the input capital B, you have typed letter B, you have typed letter C. So B and C, these two statements are getting executed because the break is not there, and due to this particular break statement available here, the control is coming out, and the end of the program is getting executed. So keeping this one in mind, what you can do, we can go for another time execution. Instead of giving capital A, if I give small a, then what will happen? So capital A, we are having a case for capital A, but no case for small a. So that's why the control is coming to the default block and you have typed the letter other than A, B, C, D. That statement is getting executed. But let us suppose I want to execute this one for capital A and also for small a. Then what should I do? Then I can do one thing. Just see here. We can go for this and we can make this one small a. So what will happen for this capital A? There is no break. So that's why control will come to this block and this block will get executed. So let me show you that one. I'm going for this small b. So if I give small b, the line is getting executed. Let us uncomment this one. So small b, the line is getting executed. You have typed letter B, and then if you give the capital B also, we are getting the same thing. So let us test with A also. Small a, you have typed letter A. We are having this capital A, you have typed letter A. So in this way you can also have your case without any break, which is very much purposeful in this particular example. So in this demonstration we have discussed that how to use the switch case construct in our Java. I think you are getting this idea. In your code also you can use this one. This particular switch case can also be represented using if and nested if, but this is a smarter way to represent. So it will bring more clarity in our code.
In this video, we are discussing arrays in Java.
In this demonstration, we are discussing how to use Java arrays. So here we have defined one array, integer type of array. Name of the array is INTARR, and this is one integer array. And while we are declaring this array, we are also initializing with our values. So that means here we are passing our values, which will be filled up in this particular array. And here it will be having 5 values are stored directly in the array from the subscript ranging from 0 to 4. In case of Java, the array subscript, the location number will be starting from 0. So this is our INTARR. Here we have defined one float array which will be having 5 consecutive locations, and it can hold only the float type of data. And we have also defined one character array which is still uninitialized, but it will have 5 locations to character to hold 5 different characters. We are having one scanner class object which has been initialized to take values from the keyboard as input. This float array, here we are initializing it. We are just putting values manually, assigning multiple different values. That means here the 5 values, float values in the array, and index will start from 0 to 4 here because we are having 5 locations. And also using for loop, we can initialize one array. You can find that here I is a loop control variable. So I is ranging from 0 to 4 because the condition is I less than 4 I plus plus starting from 0. So the value of I will be ranging from 0 to 4. And then we are going for char arr I is equal to, we shall be taking input from the keyboard using this scanner object. Next we will actually return a string, and dot char at 0, that means the first character of the string will be taken as a character, and that will be filling up this char arr array at the ith position, at the ith index. And then we are printing this integer array. So for I will be ranging from 0 to 4, and then INTARR will get printed. Similarly, we are printing this float array, and also we are printing this character array as well. So now here you can find that in this particular character array printing, we are using the for each loop, and also this float array printing, we are using the for each loop. And to print this integer array, we are using this for loop where I will be ranging from 0 to 4, and I will get increased by 1 at a time in each and every iteration. In case of for each loop, you know that float item colon float array, that means for each and every looping, for each and every iteration, one value will be picked up at a time, and consecutive values will be picked up in the order in which they are appearing in the array. And similar case will happen when we are picking up characters from this character array, one value at a time in an iteration, and the characters will be picked up in the order in which they are appearing in this character array. And then we are closing this scanner object also. So now let us go for the execution. You can find that So enter the character for this index. So we shall go for H, E, L, L, O. So we have given the 5 characters. Now the integer array has got printed. You can find that this is our integer array. So this is our integer array. The content is there. So let me go for input again. So the integer array has got printed because it has got initialized when the array was defined, and then here we are having the respective manual entries are there. So the values we are finding in this float array, and in the character array, as according to the given input, the values have got put in the respective index of this character array. So in this demonstration we have shown you that how to define one array, how to deal with array, and what are the different ways to initialize the array contents, and what are the different ways to print the array contents, either using for loop or using for each loop, and so on.
In this video, we are discussing array list in Java.
In this demonstration, we are going to discuss array list. Here we have defined one array list class object, that is our city list, which will be containing string type objects. So how to add the string type strings with this particular city list? So citylist.add Delhi, citylist.add Kolkata. In this way, we are passing multiple string class objects, and they are getting added with this city list, that is the array list class object. Now what is the size of this city list? So how many elements it is containing, so that will decide the size. So here we are expecting the size should be 5 here. So let me execute my code. I'm finding that the size of the array list is 5 here. So that is the citylist.size is actually giving us the count of respective string objects residing in this citylist array list class object. So system.out.println cities : concatenation citylist. You can find that the respective city names are getting printed. So Delhi, Kolkata, Hyderabad, Chennai, and Lucknow, they have got printed. Next, using for each loop, we are going to retrieve city name one after another for each and every iteration, one at a time. So display the content of the array list one by one. So here we are using the for each loop. So for string city : city list system.out.println city. So it will produce outcome like this. So here we are having all these city names, which are the string objects, are getting picked up one at a time in each and every iteration of this for each loop. Insert another city at the index number 2 in the city list. So in that case we can go for citylist.add 2, Mumbai. So at the second place, we know that the first place has started from the index 0. So at the second place, at the index number 2 rather, we are going to insert this Mumbai here. So let us go for the outcome. You can find that 0, 1, 2. At the second index, we have inserted this new city name, that is the Mumbai. You can find that other city names, Hyderabad, Chennai, Lucknow, which were at the second subscript, third subscript, and the fourth subscript, so they have got shifted. So now if we go on printing the size of this array list object, we are going to get here 6 in this case. So in this demonstration, we have discussed how to deal with the array list class objects in our Java code.
In this video, we are discussing thread synchronization.
In this program, we are defining one class. The name of the class is transfer. It is having only one method, that is the send message. So this is the method we are having. So this method is a very simple method. It is having one string to get printed, and then it will wait for 1 second, delay for 1 second. So that's why we have put this 1000 milliseconds as an input argument to this sleep method, which is public static void sleep long millis, which throws interrupted exception. We have discussed that one in the earlier videos also. That's why we have put it under the try block, and catch block is handling this interrupted exception. So e.print stack trace. So the respective body for this catch block is this one. After waiting for say 1 second of duration, then this message is sent, message concatenation is sent, this particular string will get printed. Now here we are having one class. The name of the class is message transfer, which extends thread. So as it is extending thread, so here we can write the override the method that is run here. Message transfer is the respective constructor. It is having one private string message and transferred object, that is the transfer class object. Here you can find that here we have defined the transfer class. So transfer class object message transfer. Message transfer is nothing but the constructor of this class, that is the message transfer, which takes the string message and transfer object trans as input argument to instantiate these instance variables within the class transfer message transfer. And here, as this particular class is extending thread class, so that's why we are overwriting the run method here, and here we have used the synchronized message transfer. You can find that this message transfer is nothing but the transfer class object, and synchronized message transfer, within this synchronized block we have called this method, that is the message transfer dot send message. That means we have called this method under the synchronized block. So what will happen when we will be having multiple objects under this message transfer class, and when for all of them we'll be calling the start method. Okay, let me discuss this one. I think that will clear your conception. So public class sync thread. So this is a class we have defined. Under this we are having the main function, and we have defined one transfer class object, that is a transfer trans is equal to new transfer, and message transfer objects, that means this class objects we are defining, so that we can call the start, method, which will call in turn the run method here. So that's why message transfer message 1 is equal to new message transfer. What is this? This is the respective message, and this is the transfer class object. You can find that we defined that respective constructor earlier, so that is the string message and transfer object trans. So the string message here is hello. In this case, for the second message transfer object message 2, we are passing this world as the string, and next time we are passing this Java as the string, and this trans is nothing but the transfer class object. We are passing that one, and then message 1 dot start, message 2 dot start, and message 3 dot start we have called. That means this particular start methods will be calling this run method. So now what will happen when this particular message transfer dot send message will be executed, this method will be executed, then other respective start methods, whatever you have called from other message transfer objects, so they cannot enter into the critical section. They'll be waiting in the queue, and because we have put this message transfer dot send message method calling within the synchronized block. So let me go for the execution. You can find that what is happening. You see, hello is sending, hello is sent. So that means this particular codes are getting executed when we call this send message. You can find that. Then Java is sending, Java is sent, world is sending, world is sent. In this way the things are taking place. So that means once this send message is been called, the respective class object, then until completion of this send message method, the next send message method, which is being called from other object, will not get initiated, and that is the purpose of our synchronized block here. So if we comment this particular block, let me tell you that what is going to happen. If you see, if I make this particular block commented, so that means this message transfer or send message, it is not under the synchronized block here. So what will happen if you go for execution? You can find that hello is sending, Java is sending, then sometimes back sometimes after we're getting this hello is sent, Java is sending here, then Java is sent. So now see, there is no synchronization. So there is no synchronization. All the send message methods are executing in parallel, and that's why the output is being obtained in a very haphazard way. And one thing is very important here. You can find that we're having this hello sending, Java sending, world sending. Hello is sent, world is sent, Java is sent. If I execute my code once again, you might be getting them in some different order. So that's why, because there is no synchronization. But if we put this synchronous block enabled here and commented, you can find that how the codes are getting executed. So I think now the conception is getting clear to you, that so hello is sending, hello is sent, Java is sending, Java is sent, and world is sending, then world is sent. So now I think you have got the idea what is the purpose of synchronous block in our Java code.
In this video, we are discussing vectors in Java.
Here in this particular program, we have defined one num vector, which is the object under the class vector and which will contain integer type objects. So here you can find that it is containing integer type objects. So integer is nothing but a wrapper class under which objects will be defined, and that those objects will be kept under this vector object num vector. So now we are going to add some items to this particular vector object. So num vector dot add is the method with the help of which you can add some items into this vector object num vector. So here we have added say 5 such objects, and these objects have got added with this num vector. So now if I want to print the size of this num vector, so that means the number of objects it is containing, we are expecting that it will print 5 here. So let me go for the execution. Here you can find that the size of the vector is being shown as 5 because here we have added 5 objects of integer type. So now we are going to print all the members of this num vector. So in that case, I've just printed this one in this way, the system.out.println numbers with a concatenation with this num vector, that is a vector object. So what is the outcome in that case? We are finding that this 10, 20, 30, 40 and 50, they have got printed. Now also we can access these members using a for each loop. Just see here, this is the integer class. Under this integer wrapper class, we have defined one object, that is a num, and using for each loop we are through the iterations we are retrieving each and every element one at a time through these iterations, and they are getting printed. As a result of that, we are getting the outcome, that is 10, 20, 30, 40, 50 got printed in the separate lines because here we have used println function here. So now we are going to add another integer object, there is a 100 to this at the location number 3. So subscript number 3, we know that in case of vector, the subscript will be starting from, the index will be starting from 0. So as the index will be starting from 0, so at the third index we are going to insert this 100. So now later we are going to print this updated num vector, that is a vector object. So we are finding that this 100 has got inserted at the index 3 here because 0, 1, 2, 3 at the third index the 100 has got inserted. So now if we go on printing the size of this num vector now, so I'm just copying this line, and if I go on printing the size of this num vector, so we are expecting that it will print now 6 because one new object of integer class has got inserted here, has got added at the index number 3. So the size of the vector object is now 6. In this way, in this particular demonstration, we have shown you that how to use vectors in our Java code.
In this video, we are discussing Java packages.
In this demonstration, we shall discuss about the package. Just see here we have defined one class, that is the mymath.java under this math package. So this is the mymath.java, the respective class name is mymath, and it is under the package math package. So here we have defined 1, 2, 3, 4 functions are there. So this function will take this a and b of double type as input and return the output a minus b. This function name is multiply. It will take a and b of double type. It will produce the product, that is a star b as return. And then we are having this double a and double b, and a by b will be the return argument, and that means that we are going for the quotient, and the function name is divide as well. We are going for this factorial. So the number whatever we are passing, so that number's factorial will be returned by this function. And here we have made the recursive function because from this factorial function the function itself has been called. So factorial we have calculated using recursion. So this is my class, that is a mymath under the file mymath.java, and this mymath.java is under the package math package. Now let us go for another one, that is a package demo.java. So this is the Java class, name of the class is package demo, and here we are import math package.mypath. So this particular class, that is a mymath, this particular class which is residing under this math package folder, so it has been imported here. So as a result of that, here we can define the math class object, that is the math, and then math.subtract, math.multiply, math.divide, math.factorial. Whatever the functions were defined in this my math class, we can easily access them from the my math object, that is the math here. So math.subtract, we are passing 2 double data, math.multiply, we are passing 2 double data, math.divide, we are passing 2 double data. In this way you can find that we are calculating the respective calculations and we are passing parameters accordingly. So if I go for the execution, you can find that after subtraction 140.23 minus 23.15, I'm getting the outcome like this. Then 8.5 into 5, we're getting this outcome in the form of double. Then 55 by 7, we're getting this outcome, that is the quotient we're getting in the term of double. You can easily find that they are actually returning long. Here they are returning 3 double type output, so it is returning double type calculated values, and the last one is the long here, and there is a factorial. We are calculating on this 6 factorial, we are getting this one as 720. You see, while calculating 6 factorial, math.factorial will be having the input argument, that is 6. So you are getting that this idea that this particular mymath.java is residing in some different folder, in some different package. As a result of that, to access them from this package demo.java, we are supposed to import math package.mypath. Then only the mypath object math can be defined within this package demo, and then we can access the respective methods defined in the class mymath.
In this video, we are discussing polymorphism function overriding in Java.
In this demonstration, we are discussing method overriding in our Java. So here we are having one class. The name of the class is animal. Only one method is there, that is a movement, and movement will have only one line statement, that is system.out.println animals can move. This is the derived class, that is dog, and animal is the base class. Extents indicate that this particular dog is inheriting the properties from this animal. So extents is actually denoting the inheritance. Here you can find that this animal is having public void movement. Here also within this dog we are defining the same prototype function, that is a public void movement, and that's why it is called method overriding, because the same method with the same prototype is being defined in the derived class also, and it is having the respective string to get printed using system.out.println. Frog is another derived class and which is extending this animal class. So this animal class is the super class, also known as the base class, and this frog is the derived class, also known as the subclass. And here you can find that it is also having the same method. Method same means the same prototype is there, public void movement. So here also the method is getting overridden. So now in this particular method we are having this statement to get printed, and that is another statement to get printed, but in between we are calling the base class method, that is the movement. So base class, whatever the name of the base class, it will be referred as super. So super.movement, that means I'm calling this movement method. So there is a super.movement, that is a call the movement method of the parent class first, and then we are printing this statement, that is the frogs can jump. Before that, calling movement method of the parent class will get printed. So this is our override method class. Name of the file is override method, and here we are having the main function. So animal having the object animal is equal to new animal, animal.movement. We are defining this animal is equal to new dog. This animal is equal to new dog, animal.movement. Here animal is equal to new frog, and animal.movement we have called it. So at first we are calling this animal.movement, then we have called the same, but here this animal has got instantiated with the dog class object, and here animal has got instantiated with the frog class object. So now let us go for the execution. You can find that animals can move. This particular line got printed from this animal movement. Here in this case, when we are calling this animal.movement, dogs can walk and run also. So this is the respective text which were defined here. Just come to this code here. So this dogs can walk and run also. So this is the movement we are having. This particular movement method we are having the respective string getting printed. and they have got defined in the dog class. So next one is that this calling the movement method. You can find that calling the movement method of the parent class, and then super dot movement, that means animals can move, so that string is getting printed because I'm calling the base class movement method. And then frogs can jump, so frogs can jump has also got printed. So in this way, in this example, we have shown you that what is function overriding and how to handle the situation. I think the outputs are quite well understood by you. Please go on typing such codes and go on doing experiments at your end to get the more clarity and better understanding of this subject.
Now let us discuss sets in Java.
In this demonstration, we shall discuss the set interface and its respective objects and how to deal with them. Here we have defined two integer arrays, list1 and list2. So, and these are the set of data it is having. You can find that some duplicate data are also present. We have defined one set interface object, that is set1. You can find that this set is this interface I is written here is under the package that is the java.util, a collection that contains no duplicate elements, and more formally set contains no pair of elements e1 and e2 such that e1 dot equals e2 and at most one null element. As implied by its name, this interface models the mathematical set abstraction. So here you can find that we have defined two set interface objects, set1 and set2 is equal to new has set. The constructor has been called here. So now we are having two integer arrays, and now we are populating this set1 and set2, adding these items, picking up from these integer arrays, at first from the list1 to set1 and then from list2 to set2. So here we have used the for each loop. So for item int item colon list1, so each and every item will be picked up one at a time, each and every integer data will be picked up one at a time, and then that will get added with the set1. And you can find that the set1 is actually the object under the interface set, and here the set will hold the integer, that is a wrapper class objects. So system.out.println, the first set will be printed and the second set will be printed. You can find that we are having this first set has got printed, so it has got printed in this way 1 2, and then it is having 5, then 6, then 12. You see the duplicate data have got removed. There is no duplicate data here, and they have got sorted automatically. So now we are having this the second one, that is the 12 4 3 2 4 15. You can find that it has become 2 3 4 12 and 15 here. Now we shall go for the set operations. The union of two sets, we have defined one set interface object, that is the union is equal to new has set, which will be containing the typecasting has been done as integer wrapper class object, and then set1. So using this set1 members, this union will get populated, and now this union is having all the items from set1, and then union dot add all set2. So add items of the set2 with the set1 items which are residing in this union, that is the interface set object. So now if I go on printing the current value of union, then I'm getting this one. You can find that all the data items are unique, all the data items are distinct, so there is no repetition of data items, and the items have been printed in the sorted form. So now we shall go for the intersection. So we have defined the one set interface object, that is the intersection, which will hold this integer wrapper class objects as its items, and intersection dot return all. Just remember this method. That method is return all, and that is useful to do the intersection of two sets, and here add all, that was used to do the union of two sets here. So return all set2. So now this intersection current content has got printed. You can find that it has got printed as 2 and 12 because 2 and 12 are the common elements between this set1 and set2. Now we shall go for the difference. So now the method will be remove all. That means at first the difference has got instantiated with the items from set1, and then diff dot remove all set2. So remove common elements from the two sets, and in this way we are going to get the updated content and the reduced content of diff. Okay, so now you see this is my set1 and this is my set2 here. We have printed them earlier. So now if you go for set1 minus set2, I'm remaining with this 1, 5 and 6, because in between these two sets only 2 is common. So 2 is common, and then this 1, 5, 6, 12 is also common here. So that's why 1, 5, 6 is the only the outcome of the difference set1 minus set2. In this way, in this demonstration, we have discussed a lot on this set interface and how to deal with its methods and how to define the respective objects, how to initialize them, and we have discussed that one into details with some sample coding.
In this video, we are discussing real type of data in Java.
In this Java program, we are going to deal with the float and double data type variables. We have defined one variable myFloat of the type float, and we are assigning 50.26 to this myFloat variable. So to convert this 50.26 to the float type, we are writing either capital F or small f at the end of the number to represent that it is a float data. And then we are printing the value of the myFloat variable. So the outcome is our 50.26. In the next example, 50 and 3 individually they are integers, but I want to do some float division between them. So that's why here we have done this typecasting. So typecasting to change integer to float, and as a result of that we will be getting and we will be observing fractional part in our quotient after doing the division. So that's why 16.666666 is the respective answer, and that has been assigned to myFloat, and myFloat has got printed. Here we are having myDouble. In case of myDouble, we know that in case of double type of data types, we will be having 8 bytes of memory space will be occupied to hold this respective variables value. So in case of float, 4 bytes. In case of double, it will be 8 bytes. On this particular variable, we have written minus 0.2356. So here we can use capital D or small d to represent that it is a double data, but by default it will be of the type of double. So I'm going for the execution. I can find that myDouble is having the value that is minus 0.2356. Here we are doing some division operation. So this particular 22, we are representing this number 22 in the terms of double. So that's why we can write capital D or small d after 22, and we are expecting that this particular quotient will have the fractional part here. So 22d by 7, so converting 22 as double, and that's why we are going to get our fractional part in our quotient, that is 3.14285714 and so on. So in this way we have shown you that how to deal with the float and double type variables in our Java code.
Polymorphism, function overloading in Java.
In this demonstration, we are going to discuss function overloading in Java. Just consider this sample code. Here we have defined 3 functions with the same name, that is area. You can find that 3 functions with the same name, area, but 3 functions are having different prototypes. They are differing in their input parameters. So one is taking only one float input, another one is taking one variable of the double type, and this particular area is taking 2 float variables and at the same time. So you can find that 3 signatures are different, but the function names are same. So this is a very good example of function overloading. So what will happen when we shall call this area function from our code, depending upon the input parameters, their respective data types or count, or the order in which the parameters are being sent. So that will decide that which area function we are calling actually. So there is no ambiguity in spite of the fact 3 functions are having the same name, area. So here you see we are passing one float side. So function to get the area of a square. So the area of the square will be calculated as side into side. Here we are passing the double radius to calculate the area of one circle. So the equation will be 3.1415 star radius, that is pi r squared. So here we are passing this float L stands for length, and float B stands for breadth. So that is to calculate the area of a rectangle. The area will be calculated as L into B. Now from the main function we are calling this area functions here, and all these three area functions are under the static, so they are declared as a static. So as a result of that, we need not to define any function overload class object to call these functions. We can directly call these functions from the static main. So area 4 comma 5, so you see here we have passed two arguments and both of them are 4 and 5, both of them are numeric. That means it is matching with this area, that is that this prototype is matching with this calling. So overload area method to find area of a rectangle. Here we have passed only one parameter, but that is 5f. F stands for float, so it indicates that this particular area has been found, has been called, and we are passing actually the side of a square. So 5 is the side of the square, that is the length is 5. Here we are passing this 6d, so d stands for double. So that's why here we are calculating the area of a circle, and 6 is nothing but the radius of the circle. So if I go on executing my code, I can find that area of a rectangle is 20, that has got calculated using 4 into 5. So that is a 4 into 5. So I'm going for this is, there is a 4 into 5 here. So area of a rectangle, you can find that this text has got printed, so area of a rectangle. And the next one we have passed this area 5f, that means we have passed one float. So here this is the side, so it is calculating the area of a square. So area of a square is 5 into 5, that is 25. Now we are going to calculate the area of a circle, because 6d, d stands for double, so this area of the circle is going to get called. So it is nothing but 3.1415 star radius. So the calculated value is 113.094. So in this way we have given you the idea that what is function overloading and how to implement it in our Java code.
In this video, we are discussing the stack class in Java.
We have defined one stack class object, that is the myStack, which will hold the integer wrapper class objects as its members. So is equal to new stack constructor. So now how to put our elements, that is the integer objects, within this myStack stack object here. So stack is the name of the class, myStack is the object under the stack class. So the method is push. With the help of push, we can put our integer objects within this myStack object. So you can find that myStack.push 10, then 20, then 30, then 40, then 50. So 50 will be at the top and 10 will be at the bottom here. So now we are going to print the size of this myStack. So as we have pushed 5 such elements, so that's why 5 such integer class objects, so that's why the size stack size is 5 here. Now we are going to introduce one method, that is a pick. This particular pick method will actually check the topmost element of the stack, but it will not delete it from the top. It will only just check the current content of the topmost element of the stack here. So when you are going for this pick, and later when you are printing, that is the myStack.pick method, we are printing the current content, whatever has been picked, it is printing 50 here. So now using this while body, so not myStack.isEmpty, so isEmpty will be returning true, and when the isEmpty will be returning true, then I should come out from this while. So that's why I have used the not operator there. So true, not of true will become false, so it will come out from this while. So that's why while not myStack.isEmpty, so that is another method we are getting defined under the stack class here. So that is our isEmpty, and here you can find that isEmpty is a method which returns a boolean, and it returns a boolean. It is defined under the actual class is a vector, and isEmpty is a method, and this vector is under the package java.util. So as this particular while will be executing until the stack is getting empty, so the while will get executed, and each and every iteration will be picking up one of the elements from the stack. So myStack.pop, pop is the respective method which returns this integer class object. We can, because here we are having this my stack, we defined that it will be holding the integer wrapper class objects, and the method is the public e and then pop removes the object at the top of the stack and returns that object as the value of this function. So in this way it will return. So let me go for the output. You can find that 50 has been returned at first, then 40, then 30, then 20, and then the bottommost element 10 will be returned at the last, and then my stack dot is empty will return true, not of true will become false, so it will come out from this while loop. In this way, in this particular demonstration, we have discussed that how to deal with the stack class objects in our Java code.
The queue in Java.
In this program, we have defined one object myQueue. This object has been defined under the interface. You can find that in the help we are finding this one as interface. There is a java.util.queue. So java.util is the package name and queue is the respective interface. And this queue has got instantiated using is equal to new linked list constructor here. So how to add members to this queue object? There is a myQueue. And this myQueue will be holding integer, that is a wrapper class objects, as its member. So to add the new elements, we are going to go for new items. We are going to go for this method add. So using the method add, we can add new items to this myQueue, that is a queue interface object. So new myQueue.add 10, myQueue.add 40, myQueue.add 50. In this way, we have added 5 such elements. We know that queue is a data structure which supports first in first out or last in last out. That means we can think that this 10 is at the front end of the queue and 50 will be found at the rear end of the queue. So now if I want to print the number of elements we are having, number of items we are having within this myQueue, there is a queue interface object. The method is size. With the help of size we can print it. How many items we have added here? 5 items. So we are expecting that myQueue.size will print 5 here. Yes, the queue size is 5. Now we are going to pick the first element. That means in this case the first element will be read, but it will not get deleted from the queue. And you can find that here we are getting this first element as 10 because 10 is at the front end and 50 is at the rear end. So the first element will be at the front end, so the value is 10, but the 10 has not got deleted from the myQueue object. It is still there, the item is still there. Now using this while loop, so myQueue.isEmpty, so when the queue will become empty, then isEmpty will return true, then not of true will become false, then we can come out from this while. But when this isEmpty will be returning false, that means the queue is still having some items, then not of false will become true, the while will continue doing the iteration. So how to remove elements from the queue? That is a myQueue.remove. So remove is the method with the help of which you can eliminate the element which will be found at the front end of the queue. So the popped item is this one. Also in case of popped item you can go for removed item, that will be better here. So the removed item is this one. So let me go for the execution. You can find that the remove item will be 10, then 40, then 30, then 20, then the rearest object, that is the rearmost object, that is the 50 is getting printed here. In this way, in this particular demonstration, we have discussed how to define and deal with queue objects.
Abstraction in Java.
In this demonstration, we shall discuss about the abstract class. So at first, let us suppose we are going for one class creation, and the name of the class say my class 1. This is a my class 1. Here we are defining 2 methods. We are defining another method, that is a void some function 1 2, and we are not writing any function body here. We are not writing the function body. Then what will happen, as we haven't written any function body, so the suggestion is that either add the body or change my class 1 dot my function 12 to abstract. If I select this option, then it will become abstract, and here we are having one error is there. Make the type my class 1 abstract. That means one abstract class will contain abstract methods. So whenever a class is having the abstract method, then automatically the class must be made as abstract. Now what will happen, let us go for another class which will inherit this my class 1. I'm going for another class. Let the name of the class is my class 2, and which is extending, say, my class 1. If you go for this, I'm finding that my class 1 is there. I'm just making this one as a super class, and it is my derived class here, subclass. So my class 2. So my class 2 extends my class 1. So here the respective function which was unimplemented in my class 1, that is that is a my function 1 2. So this particular function has to be implemented here. So what we are doing, we're just writing this statement here. So here we are going for the main function, and we are defining my class 2 object. So now ob1 dot my function 11, ob2 dot my function 12. So let me repeat once again. This is my class 1. Here one function my function 11, its body is defined. There is another function my function 122. I have written only the signature of the function, the body has not been written. So it was suggested to make the method abstract because we are not writing the body of this function my function 12, and whenever we are making this one abstract, then the suggestion is coming from Eclipse that this my class 1 should be made abstract class because it is containing abstract method. Now in my class 2, I've just inherited my class 1 to my class 2, and here we are bound to override the my class 1 to method here. If we don't want to override this one, then obviously this my class 2 will again have to be made abstract, declared as an abstract class. So here the body we have written. Now we have defined the object under my class 2, and new my class 2 is a constructor to instantiate this object, and from this object we are calling both my function 11 and my function 12. If I go for execution, you can find that my function 11 is executing, my function 12 is executing. So both the function, they have got their execution. So now what will happen if I define my class 1 object here. So as this my class 1 was having one unimplemented method my function 12, then automatically this particular my function 12 is coming down here. So it has to be implemented, then only this object 2 will have the complete declaration and definition. So that's why you can find that what I'm trying to do, again I'm showing you that here I'm just writing here is equal to new my class 1. If I go for this my class 1, automatically this code is coming. So let us suppose I'm not writing this one, I'm just writing everything manually. Okay, I'm just writing up to this. Then what is coming, you see the error message is there, cannot instantiate the type my class 1. So this my class 1, as it is one abstract class, so its object cannot be defined until we implement all the unimplemented abstract method in the respective class my class 1. So what we can do, we're just putting curly braces here, opening and closing. Now the option has got changed. Now it is asking for add unimplemented methods. So now here is the body where you'll be putting this unimplemented method. So now what I'm doing, my function 12 is executing here. Okay, so now let me go for the, so this is my class, so this a bracket is this one, so I'm coming down this. So I shall go for this ob2 dot my function 11. ob2.myfunction11, so it can easily be executed because it is a myClass1 method here, and also ob2.myfunction12. So both I'm going to implement, both I want to call and for execution. You can find that they are executing fine. So in this way, I've shown you that how these abstract classes are to be written and how to extend it in some implementing class which will implement all the abstract methods. So now let us go for another example here. See here, one class is there. The name of the class is EMP, and it is having one method is there, that is a description, and one method is there, that is a salary, which is abstract. That means we are not writing the body of the salary. As a result of that, this particular class, we are supposed to make that one abstract also. Now this programmer is another class which is extending EMP. So here the description is another method we have written, which is overriding this description here, which is getting inherited, and also it is bound to define the respective unimplemented method, that is the salary. It has to be implemented. Implemented means the respective body is to be written. We are going for another class, that is the test EMP, which is extending EMP. So here this description method is getting overridden, as we did in case of programmer. Obviously the respective body of this particular description is getting changed, and here it is calling the base class. It is also calling the base class description. So irrespective of the name of the base class will be referred to as super from the code. So super.description, that means this particular description is supposed to get executed. It is an employee and also works as a tester. So this particular string will also get printed. As it is implementing this abstract, it is extending this abstract class here. So the respective function has to be defined here. So at the rate of override, so void salary, so respective function has got defined. Now it is very simple that we are defining EMPE, which is instantiated using the new programmer, because you know that programmer is nothing but the subclass, derived class from the base class EMP. So EMPE can be instantiated in this way, and then e.description and e.salary we are going to print, and then e is equal to new tested EMP, and e.description and e.salary is going to get printed here. So let us go for the output. So you can find that we are getting the output like this. It is a programmer and salary of the programmer is 25,000. So at first we are putting this one as programmer. You can find that it is coming from here. So there is a programmer description is getting executed, not the EMP description. The programmer description is getting executed, and then obviously the salary will be executed, this one. So that's why you are getting this output. Salary of the programmer is 25,000. And now here you can find that when we are instantiating this E with this new, that is a tested EMP, the respective constructor we are calling, that means we are just instantiating employee object with the tested EMP class object. Then the description which is going to get executed is super.description, and then system.out.println works as a tester. So what will happen, you can find that it is an employee and works as a tester. So it is coming like this, and you see here we have used only print, not println. So it is an employee, and as a continuation in the same line we are getting this blank space works as a tester in the outcome. So it is, they are coming in the same line as the result of that. And then here the salary is getting executed, the salary function is getting executed, and that is the salary of the tester is 35,000, and that is getting executed. So in this way you are getting this idea that how these abstract classes are to be defined and how to deal with them.
In this video, we are discussing priority queue in Java.
When we define one class which is implementing comparable interface, you can write a sample code for you. So class say st implements comparable. So here I am putting this one as st. Then you can find that as it is one interface, it is having some unimplemented methods. So if you go on adding this unimplemented method, we are getting the method that is a compare to. So compare to will take the class object, st class object as input, and it returns one integer. So we are supposed to rewrite the code or the body for this compare to method. So we have applied the same here. So let me go for my coding. So class student implements comparable student. So private int rank and private string name. So these two are instance variable. One is a rank, another one is a name of the type int and string class objects. So this is our student is the constructor which will take this name and rank as input parameters, and they will get input arguments and they will instantiate this instance variable, that is the this dot rank and this dot name. Now there is a compare to which is there unimplemented in this interface, that is a comparable. So comparable is nothing but one interface, you can find it here, and it is defined under the package java.lang. So this is a compare to we have written. So this is our input argument will be one student class object, so let it be st. So it will compare the rank of the student with another student. So if rank is less than st.rank, then return -1. Else if rank is greater than st.rank, then return 1, otherwise return 0. So depending upon the value of this dot rank and st.rank, the either -1 or 1 or 0 will be returned as I have shown here. Also we are overwriting the method, that is a toString. So there is a string result is equal to student name concatenation rank and concatenation rank here, and return result. So string will be returned as the output argument for this toString method. So now here we have defined one class, that is a priority queue. Under this class we have defined the main function. So priority queue class object, there is a student queue, and which will hold the student class objects as its elements. So student class we have defined here. So it is nothing but implementing the comparable interface, and we also have overridden the respective method compare to. So priority queue is nothing but the name of the class, and then student is the respective objects which will be residing in this priority queue object, that is a student queue as items, and is equal to new priority queue. We are calling the constructor here. So student queue dot add. So using this add method we can go on adding or inserting new students into this priority queue. So here we are having this Ashish, that is the name, and 5 is the respective role rank rather you can say. So here you see this this is my rank will be there and the name is there. At first I'm passing this name as input parameter and rank as the second parameter here. So name is Ashish, rank is 5, name is Borun, rank is 3. You can easily call that this student is actually implementing this comparable interface. So what will happen when they will get inserted? So they will remain sorted accordingly depending upon the rank of the student. So here you see we have added 5 such student items here. So insert students into the priority queue, and but when we shall go for the printing of its content, we'll be finding them in the sorted order. So we shall come that point later. So at first we are going to print the size of this student queue. As we have inserted 5 items, so the size of the queue will be 5 here. Now we are creating one iterator to iterate through this queue. So iterator it is equal to student queue dot iterator. Now we know that we are having the method that is a has next, which is returning a boolean. So it dot has next. So when it is true, then we are printing this student queue dot poll dot toString. So in this way you are just printing this one. So student queue dot poll. So we are retrieving each and every element from here for each and every iteration, and then we are just calling this method toString, which we have overridden here, which will print the name and the rank accordingly. Remember we entered and inserted, and these new elements got added to this student queue in the order, that is Ashish 5, then Borun 3, then Monish 1, then Shovik 4, and Rahul 2. So in the execution you are finding that they are coming like say Monish 1 with the rank 1 has come at the first, then Rahul with the rank 2, then Borun with the rank 3, then Shovik with the rank 4, and Ashish with the respective rank 5 here. In this way we have given you the idea that how to deal with the priority queue class objects in our Java code.
Inheritance in Java.
In this demonstration we shall be discussing about Java inheritance. At first we are defining one base class. The name of the base class is employee. which is having protected double salary, and that is our 30,000 D. Here D stands for the double. So this particular 30,000 is of the type double here. So here we are having one constructor. The name of the constructor will be same as that of the class name, that is our employee, and one line of code is there to print one message. This developer is nothing but a subclass, and this subclass means the inherited class, and where the base class or the super class here is the employee. Here also we are defining another class, that is a subclass or inherited class, and this particular subclass is also having the same base class, that is employee. In the both cases we are defining bonus. Here it is 20,000, here it is 10,000, and here it is 20,000. And this is the developer constructor, and there is a tester constructor, and only one string will get printed in the constructor from the constructor body. So this is the total structure of the classes, and here we are having one display salary. You can find that this particular salary was under the protected section. That means they are inheritable. So that's why this salary can be accessed from the derived class, that is our developer, and this tester also, this salary is accessible. So here when we are printing the display salary, we are just adding the salary and the bonus. The salary and the bonus. Bonus is nothing but the instance variable of this developer, and salary is the inherited variable, inherited instance variable, and that is the salary, and they are getting added and the sum will get printed. Similarly here also the bonus is initialized with the value 20,000, that is a instance variable under this tester class, and this salary is the inherited instance variable. So that's why they are getting added. They can be added, and the sum of them will be the total salary going to get printed. So here we are having the class, that is the inheritance, that is a public class inheritance. Inheritance.java is the name of the file, name of the source code, and here we are defining the main function, and under this main function we are defining the developer class object and instantiating with the developer constructor, and tester class object instantiating with the tester constructor. In the both cases we are displaying the display salary method from the respective objects here. So if you go on printing, you can find here it is printing 40,000, it is printing 50,000, because the salary, you can find here the salary here in both the cases after getting inherited, the salary inherited instance variable will be having 30,000, and this 30,000 plus 40,000 for 10,000, that is a 40,000 will be the salary for the developer, and 30,000 plus 20,000 will be the salary, that is a 50,000 will be the salary for the tester here. So as a result of that, we are getting the salaries got printed as 40,000 and 50,000 for the developer and for the tester respectively. I think now you are getting this idea how inheritance can get implemented in Java code.
In this video, we are discussing commenting techniques in Java.
In case of Java, we can have the single line comment. That means one comment line can be inserted in our code. We know that comment line will not have any effect in the outcome when the program will be in execution. Comment line will be simply ignored in the execution. So here to have the single line comment, we are supposed to put // that is a double front slash, and this is a single line comment, and up to the end of the line the comment will be maintained. So that is a way to have the single line comment here. So let us suppose I want to put them in the single line comment as a block. I want to put them in Eclipse. We're having one option, that is a source toggle comment. You can find that this full block, this full line of codes, whatever the number of lines you have selected, they will be under this single line comment, and that is a toggle type one. So you can mark them and you can go for toggle comment, so they'll become uncommented. You can make them as comment. So that is our single line comment. But if you want to go for the multi-line comment, so that can be done in this way. You see the lines are not commented here, so you can go for this and go for add block comment. So in this way you can find that in case of block comment, all these lines will be enclosed within /* and // here, and that is known as the block comment. So in this way you can also do that one. You can remove it if you require to do so. Eclipse is giving us that option to do. There is a remove block comment. Respective shortcut keys are also given. You can apply them. So that is the removing the block comment. Otherwise we can also go for this. You can mention that /*. Now in this way you can put multiple lines under this comment. So I'm just copying this one. If I'm to put it here, you can easily find that you can easily put these lines under the comment. So that is another way you can do it. There is another way you can do it. So that is our multi-line comment, and you can go on expanding. So in this way you can also go for block comment in our Java. So this demonstration is for how to make a single line comment and multi-line comment, and how to take the help of Eclipse editor, the respective IDE, with the help of which you can do the same as when required.
In this video, we are discussing linked list in Java.
In this program, we shall deal with linked list class objects. So here you can find that we are creating one linked list. The object name is int list, which is containing integer wrapper class type of objects. So how to add new members to this int list? The method is add, and here you are passing 10, 20, 30, 40 and 50 as input arguments. So after adding all these members, we are going to print the size of this int list and also the current content of this int list. The size is a method with the help of which you can get the number of members this linked list is having. So let us go for the execution. You can find that it is printing the size as 5, because here we are having 5 elements, or these elements are nothing but integer wrapper class objects, and we are having the values say 10, 20, 30, 40 and 50 in the order in which they added up with this linked list class object int list. Now here we are defining one array. This is a simple array, int array, and name of the array is array, having got elements that is 5, 15, 30, 80, 60 and 25. So now we are going to define another array list. So here the array list object is arr list is equal to new array list, and then with this array list we are adding these items. We are adding item, picking up item one at a time from the integer array. And here we are using this for each loop, where item will get initialized with one of the members one at a time depending upon the iteration from the integer array. So now we are going to print this array list. So the array list size is getting printed. The method is same, that is the size, and here we are printing the current content of the array list. So here you can find that here we are printing this array list, and there we are printing that linked list here. So let us make this one, it is better, let us go for this array list. So this array list size and the respective contents are getting printed. Now let me go for the execution to show you that the linked list size is 5, the content is this, the array list size is 6, and the content is this one as we expecting. Okay, so as we are expecting, we are getting this output. Now see, in this int list we are adding all the members. So the method name is add all. We are adding all the members from the index number 2. From the index number 2 onwards, that is the array list content will get inserted from the index number 2. All the members of this array list. How many members this array list is having? This array list is having 6 members, 5, 15, 30, 80, 60 and 25. So all these members will get inserted starting from the index number 2. And later we are going to print this int list size and the current content of the int list. We know that int list is nothing but linked list class object, and which is defined to hold the integer wrapper class objects as its content. So now let me go for the execution. You can find that the linked list size is 11. Why 11? Because 5 plus 6 is equal to 11. And from the second index onwards, you can easily find that from the second index onwards, I'm just going for this, so location number 5 onwards rather. So we are going to have this set of elements, you know, we're going to have this set of elements, that is 5, 15, 30, 80, 60 and 25. They are nothing but the array list content, and they have got inserted starting from the index 2, and from the 0th place and the 1 place we are having this index number 0 and 1 is still holding 10 and 20, and from this particular index we are having this 30, 40 and 50 as usual. So in this way, in this demonstration, we have shown you that how to define linked list objects and how to call different methods from this object itself.
Interfaces in Java.
In this demonstration, we shall discuss and we shall write code on interface in Java. So at first we are going for one interface definition. So my interface name is my interface 1. So public interface my interface 1, I'm just defining two functions here. From Java 1.8 onwards, interface can also contain function with the function bodies if they are of type default or static. So let us define such functions here. So in this way we have defined my interface 1. Let us go on defining my interface 2, which will inherit my interface 1. So I'm going to define another one, my interface 2, and which will extend interface, that is our add my interface 1. So public interface my interface 2 extends my interface 1. Remember, from interface to interface we will be writing extends, from class to class we will be writing extends, from class to interface we will be writing our implements. That means whenever one interface will get implemented by a class, we will be using the keyword implements. Otherwise, between two interfaces or between two classes we will be using the keyword extends here. So now in this case we are just going to define these two functions. Okay, so just I'm going for the revision. So here we are having my function 1 my function 1 1 stands for interface 1, and this one stands for function 1 method 1. So in this way 1 1 and then 1 3 and then 1 4, it is of the type default, it is of the type static. So here also we are defining two integer quantities. We know that in case of integer it will behave as if it is of constant type. So here in this case we are also defining two member variables. Now we shall go for one class. So I'm giving this name as my class 2, my class 3 rather, which will implement the interface my interface 2. So what will happen in case of my class 3 implements my interface 2, all the unimplemented methods are getting printed, are getting defined. Just the respective bodies are to be written here. So what we can do, we are supposed to write their respective bodies. So we are writing that one. Here intentionally I'm just printing the value also. So in this way 1 1 1 2 2 1 and 2 2. Let us go for the main function, and here we are defining my class 3 object. Then ob1 dot my function 1 1, ob1 dot my function 1 3, ob1 dot my function 2 1, and ob1 dot my function 2 2. So they are getting executed. So if I go for the execution, you can find that my function 1 1, my function 1 1, my function 1 2, my function 2 1, and my function 2 2. So they are all executing. What about the 1 3? Let me go for a check. 1 3 here is the default function. So 1 3 here is the default function. So default my function 1 3 is executing, that is getting returned. So I should print that one using system.out.println because it is returning a string. So I shall go for so what about the string which will be returned? I want to print them. So in this way you can find that all these functions are getting executed and the respective values are being done. So now if I want to initialize, say data to 1 is equal to 1000, if I want to try to initialize that one, it cannot be initialized because the final field my interface 2 dot data to 1 cannot be assigned. It will be treated as if it is a constant type. So only the initialization we can do, we have done within this interface. But here where we are implementing this interface, that is in class my class 3, if I want to initialize those member variables which were defined in the interface, they cannot be initialized with some new values. So that is a very important issue. Now you see what is happening. I had another method, that is a my function 1 4. I think you can recall. That was the method called static method. So my function 1 4, you can easily find that my function 1 4 is not coming here. ob1 dot, you see my function 1 4 is not coming. So in that case what we can do, it is a static method. So I shall go for my interface 1 dot my function 1 4 can be accessed from here. So you see in this way, as it is a static method here, so it can be accessed from directly interface name dot. So let me go for the execution. We are finding that the static method is also executing. Next, let me go for another time. I'm going to define another class here. So there is a my there is a my class 4. I'm going for another class, my class 4, which is interface. I'm taking this one as my interface 2. Going for the finish. Here we can do what we are doing. We are just defining or implementing some of the methods. So 1 and 2 we are just mentioning them. Then what is happening? Add unimplemented methods. So session number 1, if I click, then those methods which I didn't implement, so the respective bodies are coming. Otherwise, another option was there, that is make type my class 4 abstract. So that's why, as we are having some methods unimplemented, the bodies we are not writing here, so I'm supposed to make the class abstract. So abstract keyword has come and the red lines have gone out. So now let me go for so here you see we are going for the main function now. Going for the main function. So let me go for my class 4. Let me go for my class 4. ob1 is equal to new. ob1 new. So now whenever we are defining an object under this abstract class my class 4, then those two unimplemented methods, the respective bodies, are to be written, and this will give us the idea that how to define objects under abstract classes. So let me go for this. I can write any other function body, so that is not an issue, only to make the conception clear. So now we are going to write one main function. So I think main function we have written already, so let me go for the execution, that will be better. So now let us go for this ob1 dot. So let me go for the execution. You can find that. So my function 1 is executing with this data, my function 1 is executing, then my function 1 then my function 2 my function 2 and also the static function, that is 1 is executing. So everything is coming according to our planning. So let us go for another class. Let me show you another important thing. So I shall go for a class my class 5. So now here we are doing, that is going for finish my class 5, and here we are defining the main function, and within this main function I'm just defining my interface 1 object. Automatically those unimplemented methods which were there in the interface, if I can define them locally, then obviously the interface objects can also be created under my class 5. This is a 1 1, this is a 1 2. So everything is fine now. So this object has got defined. So ob1 dot my. So let me go for the execution. So they are executing fine. So in this way, we are getting this idea that how to define interface and how to implement it, how to define interface object, how to define abstract class object, and so on. So let me go for the last example here. So interface demo. You can find here we have defined one interface, that is a vehicle, which is having max speed and wheel count. Two methods are there. Bike is one class which is implementing this vehicle. As a result of that, the max speed method and the wheel count, these two methods are to be implemented. We're defining another class, that is a car, which is implementing vehicle. So vehicle is the interface you can easily find. So that's why this max speed and count, wheel count, they have got these two methods have got defined here. Now you see, there is a class that is the interface demo. We are having the main function here. We have defined the bike object is equal to new bike, and car object car is equal to new car constructor, and then we are going for bike dot wheel count and car dot wheel count. As this method have got implemented within this bike and car classes respectively, so the respective methods, that is the wheel count, can be accessed from the bike object, bike class object bike, and car class object car here. So if you go for the execution, you can find that maximum speed of bike is this, number of wheels for bike is this, maximum speed of car is this, and number of wheels for car is this. Because you can find that here we're having this max speed, we're having this wheel count. So number of wheels of the car is plus wheel, we are getting this, and also we are printing this one, there is a max speed of bike plus bike dot max speed. So max speed is actually returning this respective value, which is getting concatenated with this max speed of bike and max speed of car. In this way, the outcome is very logical. The output of this program and the respective code I have put side by side so that you can see and you can get the idea. So in this video, we have discussed a lot on this interface, how to implement it, what is abstract class, how to define interface object, how to define abstract class objects, and so on.
Multi-threading extending thread class in Java.
In this program, we are going to define one class. The name of the class is thread class, which is extending the class thread. So here you see class thread class extends thread, and here we are overwriting the method, that is the run. The run method is there with the respective prototype is void multithreading dot thread class dot run. So this run method takes no input argument, it returns void, and it is under the public section. So that's why we are just overriding this method run. We know that whatever we will be writing within this run method, that is the body, that is the code to be executed when the thread will be in execution. So here we have defined one for loop here. So for I is equal to 0, I less than 10, I plus plus. So that means this loop will get on executing for 10 number of times. The iteration will be done for 10 number of times, and the value of I will be ranging from 0 to 9. And within this particular for loop, we have put this try catch block, and here we are going for this thread dot slip. You can find that this particular slip method, it throws interrupted exception. This particular slip method throws interrupted exception. So that's why we have enclosed this thread dot slip within the try block, and the catch block is handling this interrupted exception E. And you can find this that this particular slip is of the type static. So that's why public static void slip long millis. So it is taking this milliseconds in the data type of long as the input argument, which throws interrupted exception. As this method is defined under the class thread, this method is defined under the class thread. So instead of defining the thread class object as it is of the type static, so we can call it by thread.sleep. So thread.sleep, so 100 milliseconds it will be waiting, and then it will be sleeping, and then catch interpret exception e, and in the catch block we have written e dot print stack trace. So this is a class we have defined. Under this class we are having the main function. We have defined one thread class object. The thread class, whatever you have defined here, we have defined one object, that is a tc1 is equal to new thread class constructor. tc1.start, whenever we are calling this start method, the run method will be executed. That means this particular thread will be executing in parallel of this for loop execution. So this particular for loop will go on executing for I is equal to 0 to 9, and main thread colon line colon plus I, so I will be printed from 0 to 9. So let us go for the execution for the better understanding. You can see that this particular line, that is the main thread colon line colon, so this particular line has got executed for 10 times for I is equal to 0 to 9. But this this particular printing is under this for loop, and within this for loop this thread.sleep will halt for 100 milliseconds, so that's why it is go on printing in this way. So if I go for the execution once again, you can find that this for loop has got terminated earlier, and then these lines are getting printed because here we are having one sleep here, and this sleep is occurring for 10 number of times. So what we can do, we can just copy this try block here. We can also put it we're putting this try block as usual. So now if I go for execution, you can find that both the lines are having the respective 100 millisecond delay, so that's why the lines have got printed in this way. So you can find that this thread, the run function and this particular for, they are executing in parallel, so that's why the outputs are coming like this one. In this way, in this particular program, we have discussed how to define one thread class extending our thread class here. So this thread class is under the package java.lang.
Multi-threading by runnable interface.
In this program, we are going to define one thread class implementing runnable interface. So we know that in case of runnable interface, we are having one unimplemented method, that is a run. So if you write one class, say if you go for the implements runnable, and then if you put this opening and closing braces, you see here we are having one option, that is the add unimplemented method. Otherwise I can make this class abstract here. So if you go for this add unimplemented method option, you can find that there is a run method, it is supposed to get implemented. So similarly we did the same here. So here our class name is my thread class, which implements runnable and which is overriding this run method. We are writing the body for this run method, and within this body I will be ranging from 0 to 9, and we are going to print this thread.currentThread.getId and the respective value of I. So in this way the respective run function body we have defined here. So the thread, its respective get ID will return the ID of the thread, and that will get printed. So within the class, the thread with runnable, so this the name of the class is thread with runnable. So here we are defining the main function. We are defining this thread class objects, thread 1 and thread 2, and they are getting instantiated using this my thread class object. So actually we are creating the thread object with the my thread class object. So in this way you have defined this thread 1 and thread 2. So now if we call this start and func methods from this thread 1 and from the thread 2 to thread class objects, then this run function will be executed. And within this main function we are having the for loop where I will be ranging from 0 to 9, and main thread colon line colon I will get printed. So let us go for the execution for the better understanding. You can find that here this main thread line number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then for this particular thread ID, it is getting printed as a 10 and 11 for the two objects, that is the thread 1 and thread 2. So you can find that thread number 11 for this, we are having this line 0, 11 line 1, 11 line 2, 11 line 3. We are having this 11 line 9 here. So the respective I value is ranging from 0 to 9. Similarly, for thread number 10, we are having the 0, we are having this 1, and similarly we are having this thread number 10, that is the ID, it is getting printed, and line number 9, that means that here also the I is ranging from 0 to 9. So just look at this outcome, look at this output, the sequence in which it has got generated. So that means we are finding that this thread 1 dot start method is actually calling this run function, and this thread 2 dot start, this particular function calling is actually calling the run function, and also the main function. All these three functions are in execution in parallel. So that's why you are finding that all these lines are getting printed one after another in a mixed up way. So if I execute my program once again, you can find that the sequence of this execution and this line printing will be changed. You can find that. You see, it has got printed in some different sequence. If I go for execution again, it has got printed in some different sequence. You see, different times different sequences are coming. So that will depend upon the execution synchronization, in which order all these three, that is the main thread and two threads, that is our objects names are respective thread 1 and thread 2, how they are executing within this machine, and that's why the outcome is changing along with the execution.
Hash map in Java.
In this program, we are discussing hash map and hash map objects. Now, what is a hash map? So here you can find that hash table based implementation of the map interface, and this implementation provides all of the optional map operations and permits null values and the null key. The hash map class is roughly equivalent to the hash table, except that it is unsynchronized and permits null. But in case of hash table, we didn't allow to insert any null key or the null values. But here in case of hash map, the null values and the null keys are permitted. This class makes no guarantee as to the order of the map. In particular, it does not guarantee that the order will remain constant over the time also. So let us go for one hash map object. The name of the object is employee hash. It has got instantiated. It will be holding this integer wrapper class object as the key and string object as the value here. So how to add item to this hash map object? The method is put. So here the key is 12 and the value is programmer, key is 14, value is instructor. In this way we have added 5 such values there. So if we print this employee hash, then what will be the outcome? You can easily find that. So the employee hash map will be having the value, that is 18 tester 21 is equal to casual, 12 is equal to programmer, 13 is equal to programmer, and 14 is equal to instructor. You see the order in which I put all these items, so they are not occurring in the same order. And also you can find that the value has got repeated, but the key cannot get repeated here. You see the value has got repeated. So here we are having this programmer, here also we are having this programmer, but the key values are different here. So if you go for another one, say if I put this one, say for this 12, for this 21 rather, I'm putting this one as debugger. So you can find that this 21 has got updated with the text debugger here. So let us go. So it is my debugger. So I'm changing the spelling here actually. So that you see 21 is now debugger. So what is happening, as the key values are the same, so that's why the debugger is not a new item for this employee hash, but this 21, the respective value casual, has got replaced and updated by the value debugger here. So if we erase this line and if you go on executing, we can find that against this 21 key, the value is casual. Now see, we are going to search how to search a particular item against the key. So if employee hash dot contains key, 18. So you see 18 is present. So that's why the true will be the outcome. You can see the contents key is returns boolean. Contents key returns boolean, and it is under the package java.util under the class hashmap. Contents key is the respective method name which will take one object as input argument, object key as input argument. Here we have passed this integer class wrapper class object 18 as input argument, and it returns boolean to check whether the value, the key has been found there or not. So in case of 18, the type of the employee, there is a system.out.println, the type of the employee will be employee hash.get 18. You can easily find that it is printing tester, because against 18 we are having the value tester here. So tester is getting printed. But what about this 108? So 108 is this respective key is not present here, so it will go on printing the key is not found. So in this way, in this particular demonstration, we have discussed into details with the demonstration and the sample programming code, hashmap, its concept, and how to define objects, and how to define and how to access different methods from this object as well.
Hash table in Java.
Let us discuss some examples on this hash table and hash table objects. Here we have defined one hash table which will hold the string, as string is a string object as the key and integer object as the value. So we know that hash table contains key value pair. So the integer class wraps a value of the primitive type int in an object. So there is the integer, and here we are having the string class. Objects will be there, and this is our hash table. This class implements a hash table which maps keys to values. Any non-null object can be used as a key or as a value here. So here we have defined one hash table class object, that is the st hash, and it has got instantiated with the constructor. So with this particular hash we are going to add some key value pairs here. So the respective method is put. So here string is the name is the key, and here the respective integer will be the respective value here. So there is a marks we are actually having. So Ayon 65, Deepak 80, Joy 55, Torun 75, and Rahul, that is we are having here 70 here. So now we are printing this st.hash here. So let me see that how the outcomes are coming. So the student hash table is having the content, that is the Torun 75. You see, we added Torun at the 4th place, and then Joy 55 we added Joy at the 3rd place. Deepak 80 we did this one at the 2nd place. Rahul 70 we did that one, adding putting this one at the last place, and the Oyon at the 1st place. But you see, the order in which they got added to this st hash, that is our hash table object, the order has not been maintained, but the key value pair, the respective key value pairs, that pair has got maintained throughout. So in this way you have got this one. Now let us suppose I want to add another one. Say I'm going for the st hash dot put. Say if I give a same name, say if I go for say Joy, with the value say 67. So initially you see the Joy is having the value 55, now it has become 67. Then what will happen, as the key is repeating the same key, so it will be not a new entry there, it will not put a new values key value pair there. So only the Joy, its value, its marks 55 will be updated with the 67. So 55 will get updated with the value 67. So let us go for that. You can find that with this Joy we are having the value 67 here. Okay, so key must be unique, and that's why it is known as key, and value may repeat, and with each and every key there should be some one not null value. System.out.println, the student hash table and the st hash we got printed. You see, we got printed this one. Now we are doing something different here. So string max key is equal to null. So we are going to hold the name of that student who has secured the maximum marks. So int max marks is equal to 0, and max key, that is which will be holding the name, is having the null string initialized at first. So for string key colon st hash dot key set. So in case of st hash dot key set, all the key values will be there, and for all the keys in the key set, the for each loop will get executed. It will pick up each and every key one at a time in each and every iteration, and to get the respective marks against that key, we should go for st hash dot get key, and it will be compared with the max marks. So if max marks is less than st hash dot get key, then max key will be initialized with the new name, that is the key here, and max marks will be initialized with this new value, that is a marks here. So that is the st hash dot get key. Using this get key, we can get the value of the against the key whatever you are passing as the input parameter to this get method. So in this way you are doing this one. We know that here the maximum marks has been obtained by Deepak, and the maximum marks is 80. So we are printing the student name and we are printing the student's marks here. So we are expecting that Deepak and 80, we are expecting that Deepak and 80 should get printed, and it has got printed accordingly. In this way, in this particular demonstration, we have discussed how to deal with the hash table in our Java code.
Functions in Java.
In this demonstration, we are discussing Java functions. Java functions can be categorized in two different categories. One is the user-defined function, or in short can be called as UDF, where the function prototype, the function body will be written by the programmer. Another function is known as the inbuilt function or predefined function or library functions, which function bodies are pre-written and we are supposed to use them as when required in our code. A function can be recursive, can be also non-recursive. So let us go for the function examples. So a function should have a return type. The return type may be void also or any other data type. Then the function name will be there. Then optional input argument or argument list will be there. So that is a basic prototype of a function. So public static int add int a comma int b. So here the name of the function is add, and it takes the two input arguments, that is int a and int b. That means it is taking two arguments of the both of the type integer, and then it returns int. That means it returns one value which is of the type of integer. It is defined as static. That means this function can be called without defining the function class object, and this function is under the public scope, can be accessed outside of the class also. Within the function we have defined one local variable, and that is the int sum. So that is a local variable there. A and b are the input arguments, input parameters, so they will get added, and sum will hold the sum, the total of these two a and b variables, and then return sum. We know the sum is having the data type integer, so as it is returning, so that's why this function will have the integer as a return type. Next one, we are having one recursive function. We know that in case of recursive function, the function will have a capability to call itself. That means here you can see that within this factorial function body, we are calling the factorial itself. And another property will be there. A function will be recursive if it is having some base cases. Base cases means for certain inputs, the outputs are known to us. In those cases, it is known as the base case, and the recursive function will have the capability to call itself either directly or indirectly. So here we are observing the direct calling, because within the function body itself, the function itself has called. So if num is less than equal to 0, so actually you are calculating the factorial of a given number. Here the number has been passed as argument, input argument, and the variable is num. So if the num is less than equal to 1, that means if the num is 0 or if the number is 1, then we are going for this return num. So when the number is 1 or less than that, the factorial will be 1 here. So I think it will be better if we return this one as 1, because in case of 0 factorial also the return value will be 1. Otherwise what will happen, it will return num star factorial num minus 1. That means if I want to calculate the factorial of 4, then actually the factorial of 4 can be written as 4 into 3 factorial. That means we are calculating the factorial of num minus 1, and that will get multiplied with the num, and that will be returned as the output argument. So in this way we are writing one recursive function here. So let us go for the main function. So num is equal to 5, and result we have defined, res result variable we have defined. So at first we are using some library functions or predefined functions or pre-written function. Here the function is pow. So math.pow. So math is a respective class name, and it is defined under the java.lang package, and pow is a function which will take two double as input argument, and it returns the double as output. So this is the num we are passing, that is a 5, and 3 we are passing. So actually it is calculating num to the power of 3. It is actually calculating num to the power of 3. So here you see, here this num is equal to 5. So actually 5 to the power of 3 is being calculated. So 5 comma 3 has been passed, and its output argument has been done typecast to integer, and that will be assigned to res, because res is nothing but result of the type of integer variable, and this result value is going to get printed. Here we are calling this user defined function non-recursive. We are passing this 15 and 20. So this 15 is getting assigned to A, and this 20 will be getting assigned to B. So 15 plus 20 will be done, and that will be assigned to sum, and the value of sum will be returned, and the return argument will be assigned, will be will be dumped onto this result variable, and this result variable is getting printed here. So whatever the output argument is being is obtained from this add function, that will be initializing this result variable, res variable, and the result variable is getting printed. Now to calculate the factorial, we are calling this recursive function factorial, which takes only one parameter as input. So here we are passing this 6. So 6 will be assigned to num, and the corresponding factorial is going to get calculated. So let us go for the execution here. So 5 to the power of 3 is 125. So 10 plus 15 plus 20, rather it is 15 plus 20. So 15 plus 20 is equal to 35, and then factorial 6 is equal to 720. So in this way, in this particular example and demonstration, we have discussed that how to define recursive functions, non-recursive functions, how to use user-defined functions, predefined functions in our Java code, and what are the different syntaxes and what are the different issues. We have discussed that one into details with proper example.
Final keyword in Java.
In this demonstration, we shall discuss the keyword final. At first, we are showing you that how to define one final variable. So it can be defined in this way: final int variable name. So in this way, you can define a final variable. So protected int my int, and class A is the name of the class. Class A is the constructor. So in this case, so it is passing this x and y as input parameters. So it is a parameter as constructor, and fin integer, there is a final integer, is equal to x, initialized for one time only through this constructor. And this my int is having this y value. So this is my non-parameter as constructor here, and it is calling the parameter as constructor with the argument 0 and 0. So 0 will be assigned to x and 0 will be assigned to y here. So here we are defining one final method. There is a final public void display final. So always remember, this final method cannot be overwritten in the derived class. So that is the one of the properties are there of this final method. So final public void final, so it is just printing the fin integer variables value. And display my int, you can find that this particular display my int is not of type final. So that's why during inheritance in the derived class, in the subclass, this display my int can be overwritten here. So it is having a single line to print. Next one is that final class B. Whenever we are defining one class as a final, that means the class cannot be extended further. This particular class is the last class in the class hierarchy. It cannot be extended further. It cannot be treated as a base class for another class. So that is the final keyword is there with the class. So you can get this idea that final keyword with this integer can get updated, can be initialized only once in the constructor. We're having this final as a method, final method. So this method cannot be overwritten, and this our final class. So this class cannot be extended further. So final class B extends class A, and here we are defining another variable, that is a my int, and set my int is one method which is taking this x as input and which is initializing this my int instance variable here within the class B. You can find that my display my int, this method has got overridden because we are having the same prototype, public void display my int. This method has got inherited in this class B, but in the class B we are having another declaration of public void my display my int. So this is nothing but one overridden method. This method can be overridden because this is not a final method. So now it is having a single line of code to get printed. Now if I want to try to override our display final, so if I write here public void, so display final. If I want to write this body, you are getting one error message and it is telling that cannot override the final method from class A. So that's why final method cannot be overridden. Okay, next. Here we are defining the class, that is the keyword final containing the main function, and class A C1A is equal to new class A 10, 15. So that means we are defining the object of this class, and here we are passing this 10, 15. So 10 will be assigned to this fin integer and 15 will be assigned to this my int. So now we are going for the display final. It will print the final variable, and the display int, it will print the respective one. So it will go on printing this 10 and 15 accordingly. So value of the final variable has got initialized with the 10 for the first time, and the last time the final variable has got updated, and value of my int is 15 here. We are defining another object, that is a C1b, and is equal to new class B. This is another object we are defining, but it is under the class B, that means this one. And then C1b dot set my int 50. So what will happen, you can find that this 50 has been assigned, and then display my int, it is printing the value 50 here. So in this way you can find that this particular display int is printing the value of this int as 50. Here we are having my int is a respective value which has got printed here. So I think now the conception is getting clear, that what is the purpose of this final keyword with a variable, with a method, and with a class.
In this video, we are discussing comparator to short lists.
We are defining one class, that is the string compare, which implements the interface comparator. This comparator interface is defined under the package java.util, and this particular comparator interface is having only one unimplemented method, that is the compare. So this the compare is the one unimplemented method in this interface, that is the comparator. And in this particular compare we are having two input arguments, that is the to1 and to2, that is a type object 1 and type object 2. Let us go for detailed description here. You can find that compares it two arguments for the order return a negative integer 0 or a positive integer as the first argument is less than, equal to, or greater than the second argument, and that is the purpose of this compare. So compare is the method which we have implemented here, which returns return str1 dot compare to str2. Here we have passed this string str1 and str2 as two objects to this compare method. So string compare is nothing but our user defined class which is implementing the interface comparator, which is defined under the package java.util. So here we are having another class, that is our comparator demo. Under the main function we have defined one array list object, that is a city list, and we have added multiple string objects to this city list array object, and we have printed the current content of the city list. So let us go for the execution. You can find that we have printed all the current content of the city list, and when the cities are unsorted, so Delhi, Kolkata, Hyderabad, Chennai and Lucknow, they have got printed. Now sort the array list in the alphabetical order using the method sort, and as an input argument we are passing the string comparator class object which has already implemented the comparator interface and also implemented the method, that is a compare. So city list dot sort new string compare. So here we are calling the string compare class constructor. That means with the new we are actually passing the string compare class object as input argument to this sort method. So now if we go on printing this array list content, we are getting that this array list content have got sorted in the alphabetical order. So now the order has become Chennai, Delhi, Hyderabad, Kolkata and Lucknow, and you can find that they have got sorted in the alphabetical order in the ascending order. In this way, in this particular demonstration, we have shown you that how to use the comparator interface in our Java code.
Continue statement in Java.
In this demonstration, we are discussing about the continue statement, how to use continue statement in our Java code. We have defined one integer variable a initialized with the value 0. While true, that means we're going to have one infinite loop. It will go on executing forever. And here, if the value of a is greater than equal to 5 and a is less than equal to 10, that means when the value of a will be ranging from 5 to 10 inclusive of the limit values, then the value of a will get incremented and continue. That means the control will be going to this while line once again. So what will happen if you come to the execution of the statement continue, then control will go to the while directly without executing the rest part of the while body. So the rest part of the while body will remain unreachable and will remain unexecuted. Okay. So if the value of a is below 5, that means from 0 to 4 or above 10, that is 11 onwards, then the value of a will get printed. And if the value of a is equal to 15, then break, that means control will come out from the while body. Otherwise, the value of a will keep remaining incremented. So let us go for the output. You can find that when the value of a is equal to 0, 1, 2, 3, 4, this line is getting control because a greater than equal to 5 and a less than equal to 10, this condition is becoming false, so continue could not get executed. But for a is equal to 5 to 10, this particular if was true and then a got incremented, but the rest part of the code remain unexecuted, so the value of a could not get printed. Continue make the control go to the while statement once again back. But when the value of a will become 11, then the control will come to this line, so value of a will get printed. So 11, 12, 13, 14, 15. When the value of a will be equal to 15, then break is actually breaking this, breaking this particular block, and control will come out from the while body, and next statements whatever are there in the respective code will get executed. So let us put one statement here so that you can feel that really that statement is getting executed. Okay, so now let me go for the execution. You can find that after 15, the control is coming out from this while construct, and rest part of the code will get the control and they will get executed. So in this way, in this demonstration, we have shown you the use of continue statement in our Java code, and where and why we should use the continue. So that we have discussed with proper example.
In this video, we are discussing break statement in Java.
How to use break statement in Java, we shall discuss that in this session. So let us suppose we have defined one variable a initialized with the value 0 of the type integer. While true, that means we are going to execute one infinite loop, because the true means always the condition will remain true. So while true will form an infinite loop, go on executing. Within this loop body, we are just printing the current value of a, and then we are checking if the value of a is equal to 10, then break. Break means it will come out from the loop body. That means within this curly braces, we are having one loop body. So this is the loop body we are having. So if a is equal to 10, then it will come out from this loop body. That means the next line whatever there after this while will get executed. So let us put another line here for the better understanding. Okay, end of the program is a line. So when the value of a will be equal to 10, after printing this a, when the value of a will be equal to 10, then it will break, it will come out from the loop body, and the remaining part of the program will get executed. Otherwise, it will just increase the value of a by 1. So let me go for the execution. You can find that the loop is getting executed for a is equal to 0 to 10, then it is coming out from the loop body, and end of the program, that message, the string is getting printed. So you are getting the idea what is the purpose of break statement in our Java code.
In this video, we are going to discuss another looping construct in Java, that is a for loop in Java.
In this demonstration, we are discussing about the for loop in Java. So int sum is equal to 0. So the sum has got initialized with the value 0 of the type integer. And then for int a is equal to 0, semicolon, a less than 10, semicolon, a plus plus. That means here we are defining one variable and initializing it with 0. So that is a loop control variable. Here the a is known as the loop control variable. So at first the initialization, then semicolon, then you will be having one condition. Depending upon the condition, it will be decided whether the loop will get executed further or it will get terminated. And then semicolon, and then we'll be having increment or decrement factor of this a of this particular loop control variable. So at first initialization, then semicolon, then condition, then semicolon, then increment or decrement of the loop control variable value. So this is the basic syntax, the basic grammar of this for. So now when this condition will be true, then this block will get executed. What we are doing here, actually we are printing one line and then we are going for sum is equal to sum plus a, and outside of the loop sum has got initialized with the value 0. So a can have maximum value as it is getting increased by 1 starting from 0. So a can have maximum value, that is 9, and 9 less than 10, the condition will be true. So this sum can add with the values ranging from 0 to 9, because a can range from 0 to 9. Because after 9, when the value of a will get incremented by 1, when the value of a will get incremented by 1, so it will become 10. So 10 less than 10, the condition will become false. So it will come out from the loop, for loop, and this line will get printed. So let us go for the execution for the better clarity. You can find that the value of a is ranging from 0 to 9, and these values are getting added with the sum, and at the end, after getting out from the loop, we are printing that the value of sum is 45. That means when the value of a will be equal to 10, then it is coming out from the loop. So that's why if we print the value of a outside here, if you print the value of a outside of this loop, I am expecting that it will print the value a as 10 here. So let us go for the execution. One error is there, so I'm just going for this printing. Is a loop control variable, so that's why it is not having the scope outside. So it is better to go for here int a. Okay, so I'm defining this a. If we write this int a here, that means this scope will be confined within this for loop only, so not accessible from the outside. But if I define this variable a outside of this loop, then obviously it is accessible after the for loop also. So now let me go for the execution. You can find that a is equal to 10. We are finding the value of a is becoming 10. So 10 less than 10, the condition is becoming false. So that's why it is coming out from the loop. Now see, instead of having this, we are not erasing the semicolon. Instead of having this, also you can write directly here. Okay, so now let me go for the execution. You can find we are going to have the same output. Instead of writing this a plus plus, instead of writing this a plus plus here, I can also put this a plus plus here. I can also put this a plus plus here. You can find that we're having the same output whatever you are getting, but don't omit this semicolon. So semicolons should be there, but you can have this initialization statement and this increment or decrement statement in other part. If I write a plus plus here, so let me go for another experiment. If I write a plus plus, so you see for each and every iteration, a is getting incremented by 1 here and then 1 here. So a is getting incremented by 2 for each and every iteration. So if I go for the execution, you can find that the value of a will get incremented by 2 always. So after coming out from 8, it is becoming 10. So when it is becoming 10, it is coming out from the loop, and now we are getting this 10 as the final value for a after coming out from the loop. So 0 plus 2 is 2 plus 4 is 6 plus 6 is 12 plus 8. So I'm getting here 20 as a sum. So I think now the conception is getting clear to you that how to use the for loop in our Java code. And whenever we require some iteration, we require some looping, if we require some repetitive work, we can use for, we can use do while, or you can use while do.
In this video, we are discussing while loop in Java.
In this demonstration, we are discussing how to use while loop in our Java code. So here we are planning to add numbers ranging from 0 to 9, and the sum thus obtained, the total thus obtained, that will get printed, and this iteration, this looping will be done using while statement. So a is equal to 0, a will be the term which will be ranging from 0 to 9, and then sum is equal to 0, initializing sum with the value 0 here. While a less than 10, so that means 9 will be the maximum value a can take because a is of the type of integer, and system.out.println, the value of a is getting printed. Sum is equal to sum plus a. So initially the sum value was 0, and now the sum will get increased by the value of a, and each and every time a is incremented, increase the value of a. So what will happen? Initially the value of a was 0, then it will become 1, then it will become 2. In this way it will proceed, and it will proceed up to a is less than 10. So maximum it can proceed up to 9. So when the value of a will become 10, it will come out from the loop, and after exiting from the loop we'll be printing the value of sum. So let us go for the execution. You can find that we have added the value of a as 0, and then a 1 2 3 4 5 6 7 8 9. So that's why, and the sum of the numbers from 0 to 9 is equal to 45. So sum is getting printed. So what is happening when the last 9 is getting added with the sum, the a is getting incremented by 1 back again, so it has become 10. So while 10 less than 10, the condition is false. So when the condition is false, the control cannot go into the while block within the while statements. What are the statements we have written within the curly braces? So the control is coming out and printing the sum of the numbers from 0 to 9 and concatenation sum. So that's why if we print the value of, so I'm expecting that here the value of a after coming out from this while block will be getting this one as my 10 here, because the 9 plus 1, the 10 will be obtained. I think there is no error right now. Okay, let me go for the execution. You can find that after coming out from this while body, and it is having the value of a is equal to 10, and 10 less than 10 caused false. So this condition is causing false, is producing the output false. So that's why this particular while false, the control cannot go into the while body, so it has come out, and then the next statements, whatever there in the program code, they are supposed to get executed. I think you are getting this idea that how this while works in our Java program.
In this video, we are discussing file handling in Java.
In this program, we are going to discuss file handling. We shall create one file input stream class object, that is a file in, and another file output stream class object, that is a file out. Now within the try block, we are going to instantiate this file in and file out objects. So file in is equal to new file input stream. So that is a constructor you are calling of the class. Within the double quotes, we are mentioning the respective file name. Here we haven't mentioned any kind of path, so the file will get created or will be accessed from the current default path. From the current default path, the file will be accessed, and from this particular file we'll be reading some data. So that's why we have just passed this particular file name to instantiate one file input stream class object file in. Similarly, for file out is equal to new file output stream sample copy.txt. So this is the file name we are passing as input argument to the constructor file output string, and it is returning the respective references and instantiating this file in and file out class objects of file input stream and file output stream classes respectively. int c, while c is equal to file in dot read. So we are calling one method, that is a read. That means we are going to read character by character from the file, and this file name is sample.txt, and whenever the file will get exhausted, then this file in dot read method will be returning -1. So until it is returning -1, that means we have read some valid character, and the character will be written onto the file out.write. So file out is the respective file output stream class object. Here we have defined already. .write is the method we are calling, passing this car as input argument. So this is the car, we are passing this one as input argument. So we are writing character by character, reading it from the input file stream to the output file stream. So after completion, we shall go for system.out.println writing of sample copy.txt is complete. So here this try block has been followed by the catch block, that is a file not found exception E, and the respective catch block is having only one statement, that is the invalid file name is going to get printed. Finally block, you know that finally block will get executed irrespective of the fact whether the file whether any exception has occurred within the try block or not. So that's why in the finally block we have written, if file in is not equal to null, then file in dot close. Similarly for file out dot close. So this is a respective function body here, there is a main function body here. So let me go for the execution. Before going for the execution, I want to show you that this is a respective package you are having. There is a package file handling. So this is a respective package. Under it we're having the Java code, that is a file handling.java. So this is a respective Java code, that is a file handling.java. So now this is a sample.txt which is existing in the current folder. So if you double click, this is the file content. Sample.txt is having this 4 lines we are having. This is sample file. Java program will read from the sample file hello and world. So this is the content of the sample txt, and now we are going for the creation of the sample copy.txt here. Now let us go for the execution. If I execute this program, we are expecting that along with sample.txt another new file sample copy.txt is going to get created here. So I'm just executing the same. Writing of sample copy.txt is complete. That means this line has got printed from this statement. So let me refresh here. If I go for refresh, execute my code. I'm just executing once. So now let me go for the refresh. Yes, the sample copy.txt has got created. So this is a sample.txt, this is a content, and this is a sample copy.txt. You see the same content we are having, because we didn't do any kind of change. We just read character by character from sample.txt and we wrote those characters character by character on the sample copy.txt file. So in this way, in this particular demonstration, we have shown you that how to do the file handling in our Java.
We are discussing constructor of a class.
In this demonstration, we shall discuss Java constructors. We know that constructors are nothing but functions whose name will be same as that of the class name. Here we have defined one class. The name of the class is account, and we have defined 3 instance variable: name, account number, and balance. So this is known as the constructor. Here we are not passing any parameter, so that's why it is called parameterized constructor, whose name will be same as that of the class name. Where the return type specification is not there, it is under the public section, and here we are initializing the instance variable name and account number with the null string and balance with the 0.0. This is another constructor whose name will be same as that of the class name, having no return type specification under the public scope, and it is parameterized. Here we are passing three parameters, that is a string n, string id, and double b. So now what will happen, this name and this account number and this balance, they will get updated, they will get initialized with this input parameters, and then we are having the set details where we are passing this name and the respective id. The name and id will get instantiated, will get updated, will get initialized using this set details. This is my deposit money, where the money whatever will be passing as input argument, that will get added with the balance, and the balance will be the sum of the previous balance plus the money which is being passed as the input parameter. The value of the money will get added and the new balance will be there, and the balance value will get increased in that case. So now this is the get details. Actually the get details means here we are having the display function actually. So it is printing the name, printing the account number, and printing this balance with this prompt text here. So it is, they are getting concatenated with the respective texts and strings, and then the respective values are going to get displayed. So here the name of the class is constructor. So that's why you can find that we are having this constructor.java, and under the main function we have defined 2 objects under the class account, and these 2 objects one has got instantiated with the non-parameterized constructor, another has got instantiated with the parameterized constructor. So it has gone for the respective name, it has gone for the ID, and it is gone for the balance here. But in case of non-parameterized constructor, we didn't pass anything, so the name and the respective balance and the ID, they will remain uninstantiated. Balance will be initialized with 0, and name and this account number will be having the null only. Okay, next we're calling this set details to initialize this corresponding name and the ID. And deposit money, here we are passing this deposit money as 6,000 in double, and this is account SCC1, that is the first object which is having non-parameterized. So in this way we are initializing, or we are initializing this name and the ID and passing this value. So what will happen, the balance will be equal to 0.0 plus 6,000.0. so the balance will get updated with the 6,000 value ultimately after doing the addition. So now we are going to print the account 1 details. So the method will be get details. We know that get details method is actually printing the name, the account number, and the balance respectively. And this is my scc.get details. So details of the account number 2 is going to get printed here. So let us go for the execution. You can find that details of the account number 1. So details of the account number 1, this text has got printed. So get details is printing the name, account number, and balance, the name, account number, and balance. And details of the account 2, so this particular string has got printed, and it is now after that we have called this scc2.get details. So again it is printing the respective name, the account number, and the balance here. So from this respective demonstration, from this example, you are getting this idea that how the constructor can be defined and how constructor works in Java code, and we have given you the detailing and the respective output while running my code. So I think now the conception is getting clear. What is a parameterized constructor, what is a non-parameterized constructor, and how to call them and how to use them to instantiate and to initialize our instance variables.
In this video, we are discussing exception handling in Java.
In this Java program demonstration, we are discussing exception handling. Exception means erroneous condition. So within the try block, we will be writing some set of statements where we are expecting some error may take place. So here we are doing one calculation, that is int result is equal to 22 by 0. We know that division by 0 is illegal. So as a result of that, when this division by 0 will try to take place, then in that case this line will remain unreachable, unexecuted. The control will try directly will come to the respective catch block, which is just following the try block where the arithmetic exception has been caught. So how to write the catch block? Within the catch block we will be writing this, the exception name and the exception object. There is a catch the exception and handle it in a correct way. We are supposed to write the respective remedial actions to be taken when the exception will take place, and then catch block will be followed by the finally block. Obviously that is optional, it is not mandatory that always the catch blocks will be followed by the final block. In the final block we'll be writing some statements. We can put some block of codes there. What is the purpose of the final block? Whenever exception will occur in the try block, then also the final block will get executed after execution of the respective catch block. If no error has occurred, no exception has occurred in the try block, then also the final block will get executed. That means the final block will get executed irrespective of the fact whether exception has occurred in the try block or not. And then end of the program, the rest part of the code will get executed. So now let me go for the execution at first. You can find that dividing by 0 is not allowed. So that means this particular line has got the control. That means system.out.println result is equal to plus result. So that line has remained unreachable. And then the exception is java.land.arithmetic exception. And what is the error message? That is our division by 0. So that is the error message. And then operation performed. So it is coming from this finary block, and end of the program it is coming from this rest of the line after the try catch finally block. So in this way you have got the idea. So now let me make it 2 so that no exception will take place. Then result is equal to 11. That means this line has got the control. The catch block, it hasn't got the control. the control has come directly to the finally block, operation performed, that message has got printed, and end of the program, that message also got printed here. So this is the purpose of our try, catch, and finally. So let us extend this program to some more extent. So we'll be going for the keyboard inputs. So we'll be going for data 1 by data 2. So data 1 and data 2 will be taken from the keyboard as input. So here we are defining some setup of. So there is an input stream reader. So we shall go for just this one, and it is asking that it is going for the import. So it is under java.io package. So input stream reader has got imported. Next one we shall go for buffer reader. Buffer reader beer is equal to new buffer reader ISR. This is a buffer reader, so import has to be done. Java.io is the package name. Then from this buffer reader beer, we shall go for int data1 is equal to beer.readline. So I shall go for this readline, and it returns string. You can easily find that return string. So that's why I must be doing a typecasting here. So there's a readline is there, and it is telling that there is a change of type data1 to string. Otherwise we can go for integer.parseInt. Integer.parseInt. This particular string has to be converted to integer, and then again one red underline, it is indicating that add throw a declaration or surround with the try catch. So surround with the try catch, you can find that this particular parse int readline, it has got surrounded with this number format exception and IO exception. So it has got surrounded with that. Otherwise you can write in this way. I press Ctrl Z, surround with the try multi catch. So in this way you can also go for this multi catch, that means number format exception or IO exception, then this respective code will get executed. Otherwise we can go for another way. Otherwise you can write it in this way, so that is also very much useful. Also we can segregate them because we may have different remedial actions to be taken. And there is a final block we are having. So we are having this arithmetic exception, we are having this number format exception, and then IO exception there. So let me go for this. Another data has to be read, so let it be data 2, and we are performing data 1 by data 2. We are performing data 1 by data 2. So now we are having this set of multiple catch blocks are there. So let me go for the execution. All the required inputs have been done by this Eclipse. Now let us go for the execution. We are just executing the same. So we are executing, and then here we are writing the first value, say 100, the second value is say 20. I'm getting the result 5 and operation performed, end of the program. So let us go for one prompt here for the better understanding. We're executing, enter the first number, we are putting as 100, second number we are putting as 20, result is equal to 5 is coming. If I execute the same, if I provide the first number as 100, second number as 0, division by 0 is not allowed. That means the arithmetic exception has been caught and the operation performed and end of the program. Now next time, if I put the first number as say 100, the second number as say 10, then number format exception has taken place, operation performed, and end of the program is getting executed. That is, whenever we are providing 10 ten here, so that cannot be converted to integer. So whenever we are providing 10, then 10 cannot be converted to integer because we have written 10 not in 10 format but in ten, that is in the form of string. So in that case this respective number format exception has been caught here. So I want to show you one thing, that instead of writing this particular, I'm just making them comment. There's a number format exception and this, I'm going for this up to this. So now see, this arithmetic exception and number format exception, I put them under comment. And then after this catch block, we are providing exception, which is the superclass of all the exceptions. So this exception and this exception has been caught, has taken place. So now what will happen, whenever this arithmetic exception or number format exception will take place, then exception will handle the situation. Let me go for the execution. So 100 and 0, you can find that exception has taken place. So now again we are executing this 110, you can find that exception has taken place. That means instead of having this arithmetic exception catch block and then number format exception catch block, we can have a single exception catch block, that is a catch exception E. Exception has taken place, the remedial actions are to be written in here, and finally is there always will get executed even if exception has occurred or has not occurred. So this particular example I think has cleared your doubts that what is exception and how to write the exception handling program in our Java code. So let me put back my code in this case. So what about the rest of the exceptions which I haven't caught here will be caught by this exception catch block.
In this video, we are discussing enumeration and iterators.
See, at the line number 7, we have defined one string array. The name of the array is word array and containing this set of strings here. We are defining one vector class object, that is a word list, and which is getting populated directly from the content of the word array. So what is the code here? So new vector and this arrays dot as list, the method name is as list, and which is taking this string array as input, and its content will populate this vector object, that is a word list. And later we have printed this word list. So the word list colon, we are doing the concatenation of this word list, and here is the outcome for it. You can find that the word list is containing, that is the current content of this word list, that is a vector object is having this one. So book, number, place, lemon, apple and tree. In this way the word list has got the outcome, has produced the output, concatenating its content with this string here. So now here we are having another class, that is the enumeration. This particular class is having one object, that is a vector enum. You can find that this word list, which is nothing but a vector class object dot elements. So elements is a method with the help of which we can directly populate values to this enumeration object, that is a vector enum. So enumeration iterates through vector. So in this way you can find that this vector object word list dot elements is a method with the help of which we can directly populate or instantiate the vector enum, that is the enumeration class object. You can find here this particular elements, you can find that it is having the prototype enumeration string. That means it returns this enumeration class object, and this elements is under the class vector under the package java.util. So next one is that how to retrieve elements from this vector enum, that is the enumeration class object. The vector enum dot has more elements. So this is the method we are having. This method returns boolean. That means when it returns true, then the while will be continuing with the iterations. When it will return false, then while loop will terminate. So system.out of println vector enum dot next element. So next element is a respective method which returns the current content, the next element's content of this vector, that is a vector enum object, that is object of enumeration class. So linked list class object is word linked list is equal to new linked list. There is a constructor we are calling, and this linked list will be holding the string objects, and this word linked list dot add all, that is a word list. So word list is nothing but the vector class object, and we are passing this one as input argument to the method, that is the add all. In the previous video also we used this particular method add all here. So all these elements within this vector object, that is the word list, will populate, will instantiate this word linked list, that is the linked list class object. And now we are going to add another two elements here, string objects here, that is a ball and mango, and here we have used the method, that is add. Now whenever you are printing this word linked list here, so now just see the outcome. Now whenever you are printing this the word list, that is a linked list here, linked list class object, we are getting this book, number, place, lemon, apple, tree as usual, and then ball and this mango which we added at the last two elements. So they are also showing. So actually they are nothing but the string class objects. Now you see, iterator, we are defining one iterator object, that is our it, is equal to word linked list dot iterator. So the iterator it will point elements to the linked list. So here we are having this word linked list. Word linked list, you can easily find that this word linked list is nothing but the linked list class object, and dot iterator is a method which I called, and this iterator method is returning iterator class object. So while it dot has next, so in this way we can go for the iteration using this while loop. For each and every looping we can pick up the value from this iterator object it using the method it dot next. So now let me show you the output here. You can find that it is printing book, number, place, lemon, apple, tree, ball and mango as usual. So all these members have got retrieved, string objects have got retrieved with the each and every iteration and looping within the while, and while will check the condition, that is a it dot has next. If it returns true, then it will go for the next iteration, but if has next method returns false, then it will terminate the loop as well. In this way, in this particular demonstration, we have shown you how to define the iterator class objects, linked list class object, enumeration class objects, and so on. So I think the conception is now clear to you.
In this video, we are discussing wrapper classes in Java.
In this demonstration, we shall discuss on the wrapper class. Within the class, that is the wrapper class here, we are defining one variable within the main function, that is the int val is equal to 10. That means this val is one integer variable. Int res, so we have defined another integer variable res, and which is uninitialized. Now this particular val has been passed as the input argument to the integer constructor, and integer here is nothing but one wrapper class. So creating one integer type object using int. So integer is equal to new integer val. So in this way you can find that this val has been passed as the input argument to the constructor integer, and it is actually helping it to define one object under the wrapper class integer here. So res is equal to integer dot int value. That means here the value which is there within this integer wrapper class object will be assigned to this res, and res is going to get printed. So val was having the value 10, and this particular val has been wrapped within this wrapper class object, that is the integer, and from this integer we are trying to get the value now. So the respective method is init value. So respective method is init value, and that is returning the respective value there, which is getting assigned onto the integer variable res, and res is getting printed. So let me go for the execution. You can find that the value of res is 10 here. So it has got printed up to this level. Next, integer my int is equal to 50. That means automatically it is converting to my int. That means it is automatically, this line is automatically converting is getting converted to the respective statement, that is my int is equal to new integer 50. Now system.out.println, if you print this my int, that is the integer wrapper class object, actually internally it is using my init value. That is the int value, that is the respective method which you used in the earlier case also. So if I go for the execution, you can find that it is printing the value 50 here. In the next one, we are having this I123 is in the type of string, and it will be converted to this integer using integer.parseInt. If you consider this parseInt, you can easily find that this parseInt is under the public scope defined as static returns integer. ParseInt is the name of the method which takes one string class object as input argument and throws the number format exception. So as a result of that, this integer.parseInt you can write directly, because integer is the respective class name under which the parseInt is one of the member method. So as it is of the type static, so instead of defining integer class object, we can directly access this parseInt using class name dot operator, that is the integer dot parseInt. So it is just converting this string to the respective integer, and the value of this integer is getting printed. But here we are having pre-increment. That means instead of printing 123, we are expecting that it will print 124, because here it is having the pre-increment, not the post-increment. Plus sign is appearing before this res variable. So let us go for the outcome. It is printing that the value of res after increasing is 124. Next, we are having this res is equal to integer.parseInt fe, 16. So here we are passing one string. Here also we pass the string, but here the default base it was considered as the decimal base, that is a 10. But here we have mentioned explicitly that is the base will be 16, and that will be assigned to this res, and then the res is getting printed. So now you know that f means 15 and e means 14. So how to calculate this one? It is very simple. So we can consider this fe expressed in the base 16. Say I'm just writing this one in this way. Expressed in the base 16, which is nothing but that is a 15 into 16 to the power of 1. So 16 to the power 1, this one, and then we're having this one, that is a e. Is means actually this is my 14 into 16 to the power of 0. So 14 into 16 to the power 0. So what will be the value? The value will be 16 into 15, that is 240, plus we're having this one as 14, so plus 14 we're having, so fe, so which is nothing but 254. So this is the value we are expecting. Let me check that what value we got earlier. We got this 254 here. So from here we are getting this explanation. Okay, next one, long dot to binary string. So long is another wrapper class, and this to binary string is one method, and which is public static string to binary long I. So it will take the long variable as input argument, and which returns a string as outcome, and it is of the type static. So it is of the type static method. So that's why I can directly access this to binary string from this long class directly. Now here the value is 91. So let us express this 91 in terms of binary. So let me write it here. So we are having this 91. 91 is nothing but 64 plus 27. So 27 means 16 plus 11. So that means 8 plus 3. That means 2 plus 1. So in this way I can easily express this 91. So it is 64 is present. You can find here 32 is absent, 16 is present, 8 is present, 4 is absent, 2 is present, and 1 is present. So that should be the respective equivalent, binary equivalent of 91. So let me check what outcome we got here. You can find that we have got this one 1011 011 1011 011. Yes. So in this way the values have got printed. So the binary of 91 can be obtained by long dot to binary string 91. So 91 is of the type of long, which is being passed as the input argument to this to binary string method, and which is of the type of static. So that's why we can easily access it from the respective class name, that is a long dot. Long dot to hex string. So 91 will be converted to the respective hexadecimal. So what is the outcome here we are getting here, and that is about 5b. Why 5b? Because we know that 5b means 5 into 16 to the power 1. What is that? That is our 80 plus b. B stands for 11. So 80 plus 11, so that is 91. So really we are having this 91 has got expressed in terms of hexadecimal here. So the next one is that we are having this integer. We define this integer that is the integer wrapper class object integer. So integer dot to string. So respective integer value whatever is residing in this integer, that is the integer class object, wrapper class object, will be assigned to this int string object, and later the string object is getting printed. And here you see we pass this val while instantiating this integer wrapper class object integer. So if you print, we are going to get here 10 here. So in this way, in this particular demonstration, we have explained that how to use our wrapper class objects in our Java code.
Access specifiers in Java.
In this demonstration, we are discussing access specifier. Just consider this one. Under the package access specifier, we are having two classes, two Java classes. One is access specifier.java and the one is access specifier same package.java. So two Java classes under the same package, only to show that how the two classes can access their members if they are existing in the same package. So at first we are discussing access specifier same package.java. Here we are having only one class C, having our public INTP, that is a public member can be accessible from any class. INTQ, here we haven't mentioned anything private, public or protected, so it is a default scope. So default variable can be accessible from any same package, from any other class within the same package. So that means this queue will be accessible from access specifier Java class because it is under the same package access specifier. We will be testing that one. Private INTR, it is non-accessible from any other class because it is the private member. We're having the constructor passing 3 parameters to initialize 3 instance variables, and also we're having the display method which will display the current content of P, Q and R instance variables. So that is our access specifier same package.java. Now we are going for the another Java class, that is our access specifier. Here we have defined this public INTX. Public members are accessible by any class and also inheritable. Private INTY, private variables can be accessed only within this class and they are not inheritable, they are not getting inherited to the derived class or subclass. Protected INTZ, protected member can be accessed in the derived class also. This is my constructor A passing 3 parameters to initialize 3 instance variables. We're having the display method which will display the current content of X, Y, Z instance variables. Now we are having this class B which is inheriting, extending the class A. So what will happen? Public X will be inherited here, private INTY will not be inherited, protected Z will be inherited and public display will be inherited here. So now what we are doing, here we are having the respective constructor passing 3 parameters. So from constructor of B set member values of class A. So we are calling the base class constructor. The base class constructor will be can be called using the super keyword. So super A comma B comma C. So what will happen? This A comma B comma C will be assigned to this INTA, INTB, INTC to initialize the instance variable of the class A. We're having the display method here which will display the value of X and Z. Why the value of X and Z only? Because X was under the public scope and Z was under the protected scope. So they were only got inherited. Private member INTY has not got inherited in class B. So from class B, Y will be unaccessible. So X is public member of class A and Z is the protected member of class A. So that's why they got inherited and they can be accessed from the display method. We're having this access specifier. There is a last class here. Within the main function, we have there is a line we're printing. There is a data of class B. So A is the name of the class, the object name is class B is equal to new B 5, 10 and 15. So whenever we are calling this class B dot display, let us see what is happening. In case of class B dot display, we are finding that X and Z values are getting displayed. Why? That means whenever you are calling this class B dot display, actually this particular display method is getting called. This particular display method has got called, this particular display method, and that's why we could get only this X and Z values are getting printed here, because this A class object has got instantiated with the B class constructor. So that's why class B dot display is actually calling the B class display method. Next one is that we are defining another class A object, that is a class A, which is getting instantiated calling the class A constructor. So class A dot display is actually displaying the class A display method, because we are getting both X, Y and Z values are getting printed. So that means this particular display method has got called, and that's why the X, Y and Z values have got printed accordingly. Now we are dealing with the class C. C class, I told you that it was defined within the access specifier same package.java, which is another class within the same package. I told you this one earlier, they are in the same package. Now what is happening? So C, class C is the object, is equal to new C, that is constructor you are calling. Now you are calling this display, we are calling this display. What is happening? You are finding that 31625 is getting printed, because actually this particular method, display method, is printing PQR values. So using this constructor, this PQR values have got updated, has got initialized, so respective values have got printed. We know that public member variable P and the default scope variable, that is a Q, they are accessible from other classes defined within the same package. So what will happen? You can find that this class C.P and class C.Q, they have got initialized with this 9 and 56. So P and Q, they have got initialized with 9 and 56. R is not accessible from the outside of the class, so we are not trying to initialize this class C.R. So now what will happen if I type class C.R? You see, class C is the respective, you see R is not there, there is no R, so it is not accessible. So after initializing them, if I go for the display method, you can find that this 316 have got updated with 956, and then R is still with the value 25, so 25 was still there. So the class C.display is printing 956 and 25 for the respective values for our P, Q and R. So in this way, we have discussed that how this access specifier is playing such a very vital role in our Java code, and we have explained and demonstrated with the proper examples to clear your doubts and to give you more clarity on this subject.
In this video, we are going to discuss built-in exceptions.
Here in this Java program, I have defined one integer array. The name of the array is myArray, which is having 5 consecutive locations. So 5 elements we have put into this array, and during initialization of this array, we have also mentioned the size of the array. That means it is having 5 consecutive locations, and the subscript will be ranging from 0 to 4. So if any subscript, if we mention which is beyond this range, then obviously one exception will be occurring. So here we are printing the value of this array from the subscript number 10, which is quite well greater than the value 4. That is the maximum subscript possible for this array. And for this situation, one exception will be raised, and that's why we have written a catch block just following the try block here. And this catch block is handling array index out of bounds exception, and E is the respective object for that. And here we are having the remedial actions. That means we are printing one statement, that is invalid index of the array. Okay. Now next time we have defined one string string class object, that is a myString, initialized with null. And here in this particular system.out.println statement, we are trying to print the character at the 5th location. But this myString has got initialized with null. So if I want to pick up the character from the 5th index of this particular myString string object, obviously that will raise one exception. So one exception will be produced, and that's why this particular code has been put within the try block, and immediately this code is following the catch block, and that is the null pointed exception E. So system.out.println, the string is pointing to a null value. So respective string, respective message will get printed, which is the error handling part. Okay, now see, here we are trying to convert this ABC, this particular string, as an integer. So now integer dot parse int ABC string, which is not at all possible because ABC cannot be converted to a number. So that's why int number, when trying to initialize this number, there is a int variable, is not possible, and that will raise one exception, and that exception is known as the number format exception. So what will happen, this particular line will remain unreachable, unexecuted. Whenever we are trying to do this integer dot parse int, we are calling this particular method, converting one string to number, then immediately exception will be raised and the catch block will get the control here. And here the exception name is number format exception, and this remedial statement will be printed. So now let us go for the execution. You can find that whenever I'm executing invalid index of the array, that means this line has got executed. That means the control came to this array index out of bounds exception catch block. The string is pointing a null value. That means this line has got printed. That means the control came to the catch block for this null pointed exception E, and it is not a valid number. That means control came to this catch block here. So in this way you can find that how these inbuilt exceptions in Java we have handled. So now if I put this one as 1, so 0 to 4 is a valid index here because we're having 5 integers are there. So that's why one index is valid. So if I put here say 0, let us see that what will happen. And then obviously some exception will be there. And here if you put here 100, then 100, which is a string, can easily be converted to a number. So now see what will happen. So the value of the of my array 10, so here I should write this one as 1, say I'm writing this one as 1. So now if I go for this, so the value of my array 1 is 20. Yes, at the index number 0, index number 1 is containing 20. The string is pointing a null value. That means here it is producing exceptions because the string has got initialized with a null. But let us suppose I'm just putting this one as ABCD. So now see what will happen. So it is picking up the respective character 0 because I'm picking up the character from the 0th place. So A will be picked up and accordingly outputs are coming. And in the last case, the number is 100. That means this line got the control. So catch block is not getting the control. So in this way, we have explained how these inbuilt exceptions can be handled in our Java code.
C++ arrays.
Now here we are having one integer array having the name n with 10 consecutive locations, and here the subscript or the location number will be ranging from 0 to 9. So we are executing one for loop, and the for loop is extending from 0 to 9. So int I is equal to 0, I less than 10, so I can get up to 9 only, and I plus plus I will be incremented by 1 always. Ni, that is at the ith location of the n array, I plus 100. So the value of I will be at first will be 0. So 0 plus 100, 100 will be assigned. 1 plus 100, then 101 will be assigned. 2 plus 100, then 102 will be assigned. In this way, the values will be assigned accordingly. Set element at location I with I plus 100. So now here we are printing headings, that is the element and value. So if we compile our program, and if I want to show you that how the outputs are coming. So now here you see the element is the respective text. This is a respective text we are having element, and set with 13. We are having this set with 13 characters, and then value, and then endl. So here we are having 13 characters. Out of them value is having 5 characters. So here in between we are having 8 characters gap, so that we are having this output in a very columnar way. So for int j is equal to 0, j less than 10, j plus plus. So again the j is ranging from 0 to 9. So cout set with 7, and then we are printing this value j. So here you see we are having this 7 is the width, and then 0 to 9 they are the single digit numbers. So as a result of that we are having 6 blank spaces beforehand, and then numbers are getting printed. And then set 13, again we are denoting, we are having this set with 13 characters, and out of them 3 of them are getting occupied by the 3 digits. So 10 blank spaces beforehand, so they are coming. So set with 13, and nj we are printing this current value of this n array at the jth location, and endl will bring the next line, next printing in the next line. So in this way, this particular array is getting defined, array has got initialized, then array content is getting printed. So in this way, we have explained this program line by line. I think now your conception is getting clear at this particular stage.
C++ bitwise operators. Let us explain this program and also to show you that how the bitwise operation can be done in C++. So here this value of a is equal to 60. In binary it has been expressed in this way. Value of b is equal to 13. So in binary it has been expressed in this way. And c is equal to 0. Okay. Now a and b. So that means I shall be doing the bitwise ANDing. We know that 1 and 1 is 1 and 1 and 0, or 0 and 1 or 0 and 0 will produce output 0. So if you do this bitwise ANDing, I'm getting this 1 1 will survive and all other rest bits are getting ANDed with either one of the zeros will be there. So as a result of that, the output will be like this, which is nothing but 12. So if you print the value of c here, so I'll be getting 12 here. So in case of odding, the output will be like this one. The decimal equivalent is 61. So accordingly, it will get printed. So 61 is supposed to get printed here. Okay. Now here we are having the respective values, that is a XOR b. So a XOR b means we know that 0 and 1 and 1 and 0, their XOR will be 1. Zeros are 0 and ones are 1, the XOR will be 0 in that case. So similarly, if we do this XORing, so XOR will be denoted by this particular upper caret symbol. So there is a representation of XOR. Okay. Now, so if you do the XORing between this a and b, so then the output will be obtained as like this one. So you just go on doing the XORing, we will be getting this output like this, and that will be 49. So 49 is supposed to get printed here. So here we are doing this complement. Complement means ones complement. So 0011, 1100 will be converted to 1100 and 0011, and which is nothing but minus 61, because here this one will indicate the number is negative and the respective value will be obtained by taking the 2's complement of that. So it is minus 61. So value will be minus 61. So line 4, the value of c is this. So let me execute the code also side by side. So here we are getting this, that is c is equal to minus 61. Okay. Now next one is a. There is a double arrow. This particular double less than symbol will indicate that we are moving this a. All the bits in a will be shifted towards the left hand side. So left shift will take place for 2 bits position. So ultimately we are getting this value, and this value is nothing but 240. And here we are doing this right shift for 2 places. Right shift for 2 places. So here is the respective value whatever we are going to obtain. So if we do the left shift for 2 places, then in that case 2 bit positions, then in that case these 2 zeros will disappear. And if we do the right shift for 2 places, 2 bit places, then these 2 zeros will be disappearing and the free space will be filled up with zeros. So as we did here, so it is nothing but 15. So similarly we are getting this output like this. Now let me execute the same code. Now let us execute the same code in our GNU. So G++, program name is prog16.cpp, minus o a.exe will be the output file name. So if I execute the code now after compilation, we are getting the same output which we obtained in case of dep C++ output. So in this way we have explained the execution of this program, and this program is dealing with different types of bitwise operators. C++ relational operators. We are going to execute our code and we shall explain the output line by line. So here we have done the compilation and run. So here we are using dep C++ for the execution of our code. So this is the respective output. So a is equal to 21, b is equal to 10, and c is defined but uninitialized. So a is equal to b is false. So that's why the control will be coming to the else part, and line 1 a is not equal to b. So line 1 a is not equal to b has got printed. Now a less than b, a is equal to 21 and b is equal to 10, so a less than b is false. So the control will be coming to this else part. So line 2, a is not less than b, a is not less than b, so a is not less than b. So the corresponding output has been explained logically. So now if you go for the next part, that means a greater than b, and here it is true because 21 is greater than 10. So line 3, a is greater than b is going to be printed. So line 3, a is greater than b has got printed. So now here we are having a is equal to 5 and b is equal to 20. So now if I go on printing, a is equal to 5 and b is equal to 20. So if a less than equal to b, so a less than equal to b is true. So line 4, a is less than or equal to b. So line 4, a is less than or equal to b. And b is greater than equal to a. Line 5, b is greater than or equal to a. So b is greater than or equal to a. In this way, we are getting this output logically explained. C++ logical operators. Now let us explain this program with the execution. Here value of a is non-zero, that is 5, and b is also non-zero, that is 20, and c is uninitialized. So a and b, here we are doing this particular logical operation. So here is a logical operator AND. So a and b, here we are getting the line 1, the condition is true, because here a is non-zero and b is also non-zero. So now non-zero means both are true. So true and true will be true. So the condition is getting satisfied and the output is obtained. So let me execute the code at first so that we can have the better understanding. So let us execute the code in GNU++. So we are having this compiler G++, and then our program name is this one -o. The output file will be say a.exe. So after compilation, if I execute, I'm getting line 1 condition is true. So really I'm getting this line 1 condition is true. A or B, here both A and B are non-zero, so both are true. So true or true will be output will be true. So line 2 condition is true is getting executed. So now a is equal to 0 and b is equal to 10. So a and b will be returning the value 0 here or false here, because 0 means false and non-zero means true. So false and true output will be false. So condition will be going, the control will be going to the else part. So line 4 condition is not true. So line 4 condition is not true. So the output is coming accordingly. And if you take the negation over it, so if we do the complement of that, then we are getting line 5 condition is true. So line 5 condition is true is coming accordingly. So if we do the compilation and if we do the execution in C++, we are supposed to get the same output. Really, we are going to get the same output as we got in case of GNU C++ program compilation output. So in this way, the program has been explained. C++, the hash operators.
In this program, we are going to define the usage of the operator hash. We know that operator hash causes a replacement text token to be converted to a string surrounded by quotes automatically. So here you see, here we have written this mkstr hello C++. So please note that here this hello C++, this particular string is not enclosed within double quotes. So we have defined one macro here. So hash define mkstr x hash x. So that means this particular x is nothing but hello C++, and it will be enclosed within double quotes, and accordingly the output will be obtained. So now let me execute my code. So I have clicked on compile and run option, and now if I execute my code, I'm getting this hello C++. So thus we have explained the usage of operator hash, which is causing a replacement text token to be converted to a string surrounded by quotes.
C++ hash operators.
Here we have defined concat a comma b, a hash b. So in this program, we are supposed to discuss the usage of the operator double hash. And when this concat appears in the program, its arguments are concatenated and used to replace the respective macro. So here we have used this concat x comma y. So now this x and y will be coming down here, so they will get concatenated, so they'll become the variable xy, and here we have initialized this variable xy with the value 100. In the similar way, str and 1, so when they'll be coming to str and 1 to a and b, then obviously this str and 1 will get concatenated. So as it is hash defined, so preprocessor will come into the play, which you replace this particular part by xy, and which you replace this particular part as str1. So the respective variable xy content will get printed, and respective variable str1 its content will get printed. So preprocessor will come into the play, which will do this macro substitution, that means replacement of this particular macro called by the respective macro body. So now let me execute my code, and I'm expecting 100 and hello world going to get printed as the output of this program. And according to our planning, yes, we have got this 100 and hello world has got printed here. And this is a very good example of uses of hash operators and macro substitution.
C++, the raise function.
In this program, we are going to discuss this function raise. You see, like the previous program, here we have defined one signal handler function, and here is a signal function which requires two arguments. The first argument as an integer which represents the signal number, and the second argument as a pointer to the signal handling function. When the signal will be generated, how to handle the function, how to handle the situation, that will be written in the respective function code. So in this way, we have written this signal handler here. We could have given a separate different name according to our wish to this respective function as well. So now here you see, here this value of I is equal to 0 initially, and this while is not falling in an infinite loop. It is just going for I is equal to I plus 1, that is plus I here we have done. But when this value of I is equal to 3, that means when this value of I is equal to 3, then we are raising sig int. So in this way, when the value of I will be 3, then the signal int will be raised and the corresponding program will halt here. Okay, and each and every time after printing going to sleep once, it will wait for 1 second delay. To have this particular function running, we had to include this respective header file, that is unistd.h. Okay, now let me execute the code at first. So you see, if I execute the code in dep C++, the output is coming like this one. So interrupt signal 2 received. So here this value of this signum is 2 here. The value of this signum is 2 here. So accordingly, it is getting printed.
C++ pointers to structures.
Let us explain this program. So here we have defined one structure variable. The name of the variable is books, and which is having 4 fields. First 3 fields will be of string type, so that's why we have defined character arrays for them, and the last field is of the type integer, which is containing the book ID. Here we have defined 2 structure variables. One is the book1 and another one is the book2. So now to initialize first 3 fields, we have used strcpy function so that we can copy these values to the respective fields as well, and this is the book ID has got initialized. Similarly, for book2, we have initialized all the 4 fields with the respective values. In the print book function, this is a print book function which is taking one address of the structure variable. So that means it is taking the address of the structure variable book1. So as a result of that, the respective prototype for print book will be struct books pointer, and it is returning nothing as output argument, so its output type will be of void. So it is returning nothing, so the output type will be void, and it is taking structure variable address as input argument, so that's why the input argument data type will be struct books pointer. We know that in case of prototype declaration,
this variable name is optional. So instead of writing this struct books pointer book, we could have written only struct books pointer. Okay, now see, that is the function body. Here we have defined the function body. So struct books pointer book is there. Now to access the respective fields, I cannot use the dot, that is a membership operator, because here this book is not a structure variable, but it is a structure pointer variable. To access its respective fields value, I must be using implies, that is minus greater than implies operator. So book dot title is not applicable here. So book implies title, book implies author. In this way we could have retrieved all the 4 fields value. So let me execute the code at first, so that we can get the idea that how the outputs are coming accordingly. So we have initialized book 1 and book 2, and also we have printed book 1 and book 2 respective values, and you can find that the values are coming quite perfectly. So here instead of using book dot title, we should be using here book implies title, as book is not a structure variable, but it is a structure pointer variable. C++, the namespaces with directives. In this program, we have defined 2 namespaces. The namespaces, the first one is the first space and the second one is the second space. In the first space, we have defined one function with this body, and in the second space, we have defined the same function with the same prototype, but the body is containing the statement like this one. So now int main, from the main function, I'm calling this func, func. This particular function has been called. But if we use this namespace first space before this particular main, the function body, then in that case, let us see that what will be the output. As we have written using namespace first space, so this first space, the respective function, that is the func, this function will be called this one, and as a result of that, inside first space, that message will get printed on the screen. So if we change this one, if I make this one as second, if you go for the second space in that case, then we are expecting that this particular function func is supposed to get executed, and inside second space this message is getting printed on the screen on the console. So in this way we have got the idea that how this namespace is playing a very vital role in the decisive factor that which function is going to get executed when both the namespaces with the different names but having the same function prototype but with the different body as well. I think now the conception is getting clear to us. C++, the signal function. In this program, at first we shall register the signal sigint and the signal handler function through the signal function. So here is a signal function for us. We have called this signal function, and the first argument as an integer which represents the signal number, and the second argument as a pointer to the signal handling function. That means when that corresponding signal will be generated, then what is the respective activity we are going to do. So that has to be maintained or mentioned in the signal handler function. So here you see, here we are having this main function, and the main function has gone for an infinite loop, and it will go on printing going to sleep, and that is one sleep function we have called, which will make the program halt for 1 second. And in this case, to have this particular function defined in this respective header file, so that's why we have included this one. Okay, now let me execute my code for the better understanding. So now when I shall execute, when I shall click on compile and run option of this dev C++, then we are finding this each 1 second we are going to get going to sleep, this message is getting displayed until I press Ctrl C from my keyboard. So if I press Ctrl C, then I'm coming out, and the last line printed was this one. But as the corresponding output screen has gone off, so that's why we could not see the output properly. C++ class member functions.
In this program, we have defined one class known as box. The name of the class is box. Under the public scope, we have defined three member variables: length, breadth, and height of type double, and four member functions. And first member function is get volume, and other member functions are setter functions, that is set length, set breadth, and set height. So here we are having this member function declarations. So outside of this particular class, we are going to define the respective member function bodies. So that's why we should be mentioning that this particular member function is of the box member function. So that's why we have used this one as scope resolution operator. So get volume will just multiply this length, breadth, and height, and the value will be returned. We know that length, breadth, and height, all of them are of the type double. So the return argument after doing the multiplication will remain as double type. In case of set length, the input argument len of type double will be assigned to the member variable length accordingly. So BRE is getting assigned to the member variable breadth accordingly, and this height has got initialized with this input argument, that is HEI. Now in the main function, we have defined two objects under the class box. One is the box 1, another one is the box 2. The double volume variable has got initialized with value 0 after defining. So now we are calling all the three setter functions to set this length, breadth, and height of the object box 1. Similarly, for box 2, we have called the respective all setter functions. Now to calculate the volume from box 1, we are using the member function get volume, and the volume is the output argument, and the volume is getting printed, and then volume is equal to box 2 dot get volume, and then here this volume is getting printed, and return 0 is the return value of this main function, as main function was supposed to return one integer. So in this way the program has been written. Now let me execute the program through the option in this IDE dev C++, compile and run. So if you run this code, we are getting this output like this one. So volume of box 1 is equal to 210, and volume of box 2 is equal to 1560 accordingly. So this volume have got calculated through the member function, that is our get volume. Okay, now let me execute the same using GNU++ compiler. So I'm going for this one. So G++ proc62.cpp -o output is A. So a.exe will get produced after doing this compilation successfully, and then we are executing the code by issuing the file name a.exe. So A is there. So volume of box 1 is 210, and volume of box 2 is equal to 1560. So you see the dev C++ output and this GNU C++ compile program output, they are same. In this way we have explained how this program is getting executed. We have explained the program execution line by line.
Operator overloading in C++.
Here we have defined one class. Name of the class is box. It is having three setter functions: set length, set breadth, and set height, to initialize these three member variables defined under the private scope, and they are of the type double. We have defined another function here, another member function, and which is nothing but overloading the plus operator. So it is returning a box class object as output argument, and which takes one box class object reference as input argument. So it is defining locally a box class object box. Its length, breadth, and height is getting initialized by adding this implies length plus b dot length, this implies breadth plus b dot breadth, and this implies height dot b plus height. Here this is nothing but is known as this pointer, and which is referring to the current object from where
this operator plus overloaded function is being called. So it is defining or referring to that object from where this operator plus overloaded function will be called. And in this way it is just adding the current object's length and this input reference object as parameter passed as a parameter its length, and these two length values are to be added to give the length of this locally defined object box length. So in this way we have initialized them, and at the end we are returning this box object. So that's why its output argument will be of the type box. So now here we have defined three box objects under the class box, and they are box 1, box 2, box 3, and this volume is initialized with 0 of the type double. So here we are initializing using the setter functions the length, breadth and height of box 1, and similarly also for box 2. So now box 1 dot get volume is being assigned to volume, and later this volume is getting printed. Box 2 dot get volume is being assigned to the volume variable, the same variable, and the volume is getting printed here. We know that volume we have defined under the main function of the type double initialized with 0.0. Okay, now box 3 is equal to box 1 plus box 2. So this box 1 plus box 2, here we are passing two objects with this plus operator. This particular calling, implicit calling of the overloaded function plus, and actually here we are getting the same, so it is calling this overloaded function class, overloaded function plus here. Okay, now see, so box 1 plus box 2 is now getting added and box 3 is obtained, and then box 3 dot get volume will do the rest for us. Okay, now let me execute the code once for the better understanding. If I execute the code, I'm getting this, so 6 into 7 into 5, so we are getting this one as 210 as the required output. And when you were multiplying 13 into 12 into 10, when you are multiplying 12 into 13 into 10, we are getting the value as 1560. But when you were calculating this box 1 plus box 2, that means this 6 and 12 are getting added to decide the box 3 length. So 18 will be there, 7 plus 13, 20 will be for the box 3 breadth, and 5 plus 10, 15 will be the box 3 height. So now when we are calculating the volume of them, actually we are multiplying 18 into 20 into 15, and we are getting the value as 5400, and thus the volume is getting printed at the end of our program. So this is the required output here. So if we execute the same program using GNU C++, so let me see that what is the output there. So G++, and here the name of the program is proc66.cpp -o. Let us suppose we are producing the output file as a.exe. So compilation is getting done, it has been completed, and A has got executed. I'm getting this required output as obtained. So we are getting the same output in GNU C++ compiled version of the program and this dev C++. Now let me write this particular line in another way. So we are writing this one as box 1 dot, we can write this one as box 1 dot operator plus box 2. We're getting the same output like this one. So this is actually the explicit calling of the overloaded function operator plus. This is the explicit calling of the overloaded function operator plus. So let me write the same, but here I'm just swapping this box 1 and box 2 object names. So we are getting the same output as we obtained previously. So we can write this one Otherwise we can write box 1 plus box 2, and that is the implicit calling of the overloaded function plus. Program has got compiled and output has been obtained as well. So I think now your conception is cleared. What is operator overloading? Joining and detaching threads. In this program, we shall discuss regarding the thread joining and thread detach. The thread join function is the main function which will be discussing in this particular program. It is actually a subroutine blocks the calling the thread until the specified thread ID thread terminates. When a thread is created, one of its attributes defines whether it is joinable or detached. So as a result of that, we should make that particular thread joinable, then only the thread can join, otherwise the thread cannot be joined. So we can say that only threads that are created as joinable can be joined. If a thread is created as detached, it cannot be joined further. So now in this case, here we are having the same sort of coding which we had in our earlier program. So here the name of the function has got changed. So we have made that one as wait, and it is taking one generic pointer t, and this is a long, and here this tid is getting initialized with this sleep function we have called here. These messages are getting printed, and p thread underscore exit function is being called when null has been passed as the respective status. So when the child threads will be created, then this particular wait function will be called, and at the end the child thread will be releasing its space after getting terminated. So this is our main function. So here we have defined one threads array of size 5, and it is of the type pthread underscore t. So here we are just initializing the thread attributes, and we are making this particular thread as joinable. So here we are creating the child threads using the function pthread underscore create. We discussed this one earlier also, that pthread underscore create requires 4 parameters. So first one is the thread reference, second one is the attribute to be passed, third one is the respective function or the start routine going to be executed when the thread will be initiated, and then the last one is the argument to be passed, and its return value will be assigned to RC, and RC is of the type of integer. And if the RC is true, then it will indicate that the child thread could not get created successfully, so then it will print this message, and exit -1 will indicate abnormal termination of the code. And here we are having this thread attribute destroy, and that is reference of the attr has to be passed. Now here you see we have used this particular function, that is pthread join, and it requires 2 arguments. One is the thread ID and another one is the status, and the return value will be assigned to RC. So if the RC is true, then unable to join, the thread could not join with the other thread mentioned as the thread ID. So then exit -1 will indicate abnormal termination of the code. And main completed thread is I. So when the thread will get completed, then it will print the value of I, and exiting with the status this and that. So whatever we are going to print is in front of us, and we shall be getting the respective output accordingly. So when all threads will get completed, all the child threads will get terminated, then that program exiting this code will get executed, and the main thread is getting terminated using the function pthread underscore exit and passing null as the status. So now let me go for the execution. Let me show you the execution of this particular program. So here is the respective output for us. You can easily find that initially the threads are getting created. Okay, so that is the main creating thread 1 and then thread 2 and thread 3 in this way. So this is a line which was supposed to get executed when these lines were got printed. Now slipping in the thread and thread with ID 4 exiting, thread with thread with ID 3 exiting. So these threads are exiting accordingly, and see when the all threads have got their termination, then only
the program exiting this code has got executed, because this is the code which will get executed only after termination of all its created child threads, because we made this particular thread as joinable, and you know that in case of after joining, the thread can get executed only if termination of the thread id mentioned in the joining pthread underscore join function. So in this way, when completed thread id 0, then 1, then 2, then 3, then 4, then main program exiting this particular code got executed and main thread has got its termination ultimately. I think now the conception is clear because we have explained our program line by line.
C++ dynamic memory allocations for arrays. In this program, we have defined one variable, that is int row, initialized with the value 2, and another variable int call, initialized with the value 3. So here we have defined one variable p value, which is double pointer. That means it is pointing to a block where address will be there, and at that very address it will be getting the required double data. So now this p value is pointing to a block where this row number of, that means 2 locations are occupied, 2 locations are there, and their starting address will be assigned to p value here. So this row here initialized with 2, so that means this p value will be pointing to a memory block which is having 2 subscripts, 2 locations, location number 0 and location number 1. And at that very location, addresses will be there. If you go to the respective address, then double data will be there. Now, int I is equal to 0, I less than row, I plus plus. Now for this p value, at the 0th place and at the row minus 1, that is 1, at the 0th place and at the 1 place, we are just defining one array of the size 3, and that array, that memory blocks starting address will be assigned to at p value 0 and p value 1. So it is actually, p value is actually working as an index which is pointing to some memory blocks where 3 locations are there which will be containing double data. So now at first we are getting the values from the keyboard as user input and initializing locations with user input. So we have got this nested for loop, and then we have printed the respective row and column number so that the user can get the guidance that at which row and at which column they are supposed to put the data, and this value taken from the keyboard as input will be assigned to p value rc. Similarly, we are going to display the current content in p value, and in this way we have displayed the content of the p value. So now let me execute the code for the better understanding. So now here we are running this program in GNU C++ compiler. So here the name of the program is proc74, and here we are having this output file as a.exe. The program is getting compiled, and now I'm executing the code. Intentionally, I'm putting this data to indicate that row number 1, column number 1, row number 1, column number 2, row number 1 and column number 3, row number 2, column number 1, row number 2, column number 2, and row number 2, column number 3. So in this way, I've given this data in a very systematic way so that you can feel that how the data is getting is just putting into the memory locations according to our planning. So in this way, you can see that this p value is pointing to actually one two-dimensional array. So let me execute the same code in dep C++, and here we'll be putting the values in the same order, whatever we had a plan. So here we are putting the values similarly. And we are getting the same output here. In this way, we have shown you that how this dynamic memory allocation can be done for a double pointer variable. C++ nested namespaces. In this nested namespace example, here we have defined the namespace first space. Within this particular namespace first space, we have defined one function func, func, and this is the respective body. Within this namespace, we have defined another namespace, that is a second space, and the same function prototype, with the same function prototype, func function has been defined with this respective body. So this is our outer namespace and this is our inner namespace defined under this. So that's why it is called nested namespace. Here before this main function, we are writing using namespace first space colon second space. So from the main, if we call the function func function, then we are expecting that this line is getting printed on the screen. So let us go for the execution for the better understanding. So here you see inside second space, this particular message has got printed because I have mentioned first space colon second space. But if I write only using namespace first space, just erasing this part, then we are expecting that I'm just taking this part away. We are expecting that inside first space, that means this function func should get executed, because here we have mentioned using namespace first space. You see inside the first space that message has got executed, that means this func function has got its execution. In this way we have shown you what is a nested namespace and how this nested namespace can influence whenever you will be calling some function for its execution. Thanks for watching this video.
C++ operator precedence. So let us explain the output of this program, and here we shall explain line by line what is happening. So here this A, B, C, D, E, these are the variables we defined. A, B, C, D, they are having their initial values as 20, 10, 15 and 5 respectively. E is defined but uninitialized. So A plus B means here 30 into 15 by D. So 30 into 15 by this D means 5. So here we are supposed to get the value as 90. So in the first line, the expression will produce the output as 90. So we have defined this E has got initialized with this expression's output, and the value of E is getting printed at the end. Okay, now in the second case, what is happening? You are finding this one as A plus B. So that is 30 into C, that is 30 into 15. So that is 450 by D. So D here is 5. So again we are getting back this 90. So as an output. So in case of the third one, A plus B is 30 and C by D is 15 by 5 is 3. So 30 into 3, so 90 will be the output respectively. But in the last expression, B into C, so B is 10, C is 15, so B into C is 150 by D. So 150 by D, here we are getting this D as equal to 5, so 30, and A is equal to 20, so 20 plus 30, so 50 will be the respective output. Yes, we are getting this 50 as the respective output. In this way, using this operator precedence and using this particular program, how the outputs are getting obtained, we have explained line by line. Multiple inheritance. In this program, we are having one class, name of the class is shape, and two member functions set width and set height. Also, we are having two member variables under the protected section, that is width and height. This set width is taking input argument as in case of set height, and they are initializing width and height respectively. There is another class, name of the class is paint cost, and which is taking area as input argument for the member function get cost, and this area is getting multiplied with 70. Let us suppose that 70 is the cost of doing the painting per unit area. So it is returning the cost of doing the painting of the given area. So that's why its output argument is int.
Here you have defined one class known as a rectangle, which is having multiple base classes, and from there we are getting the flavor of multiple inheritance. That means from the multiple base classes we are getting one derived class. So this rectangle is having only one member function, that is get area under the public section, and which will multiply this width and height. And obviously this width and height, they are coming from the class shape, because within the class shape we know that this width and height, they were defined under the protected sections. We know that those member variables or member functions which will be defined under the protected section will be inherited, and they are inheritable. So that's why from the class rectangle I can easily access this inherited width and height member variables, and to calculate the respective area, and area will be returned with the data type of integer. So now within the main function we have defined one object under the class rectangle. The name of the object is rect. We are having one int area, so area is of the type int. Rect dot set width 5, rect dot set height 7. So width and height, they are getting initialized with the value 5 and 7, and this set width and set height, they were under the public scope, so they got inherited into the derived class rectangle already. So that's why I could set them using the value 5 and 7. So get area will take this, will calculate this multiplication of this width and height. So as a result of that, the product will be obtained in the variable area. So if we multiply 5 and 7, so 35 will be assigned to this variable area. Now rect.get area, also we are printing this 35 as the output, and now we are passing this area which was initialized here as input argument to get cost. So this 35 will be multiplied with 70 to calculate the respective cost, and the cost will get printed. So rect.get cost, in this way the member function get cost has been accessed, and this get cost was defined under the class paint cost, and this set width and set height, they were defined under the respective class shape. So from the shape, set width set height got inherited from the base class paint cost. This respective get cost member function have got inherited. So in our rectangle object rect, we have called all the respective member functions got inherited from either one of the base classes. So now let me compile and run the code. Let me show you that if I want to calculate the area out of this width and height 5 and 7, the area would get calculated as 35, and if you multiply this 35 with the value 70, then we are getting this $2450 as the cost. So let me execute the same code using our GNU C++. So here the program name is prog64.cpp, and output file name is a.exe. So after compilation, a.exe will get produced, and if I execute, I'm getting the value 35 and $2450 as we got from the dev C++ program output. Thanks for watching this video.
Function overloading in C++.
In this program, we have defined 3 member functions with the same name, that is print. And here the class name under which this member function has been defined under the public scope is print data. So class print data is a class name under the public section. We have defined this void print inti. So this print is taking integer as input argument. This print function is taking one double data as input argument, and this print function is taking one string as input argument. So all the function names, all these 3 function names are print, but their prototypes are differing considering their input arguments. The first one is taking integer, second one is taking one double, and the third one is taking one string. And here whatever the input arguments are there, they are getting printed accordingly. So in this way they are getting printed accordingly.
So now we are defining, we are writing our main function. Under this main function, we have defined PD as the object of the print data class. So PD is the object and print data is the respective class which we defined earlier already. Okay, now, so this is our print data class and this is the print data class object PD. So print 5. So when you are passing one integer, then the first member function is getting printed, because from this very input argument integer type, it is quite obvious that it will get matched with this the first member function definition, that is void print inti. Next time we are passing this 500.263. So 500.263, so it will be calling the second version of this print overloaded member function. And whenever we are passing hello C++ as input argument, it is quite obvious that we are passing a string, so the third version of this print member function will go on executing. So for the better understanding, it is better to go for the execution output. So we have clicked on the compile and run option and we are finding that printing int, so the first function has been called, 5 has got printed. Printing float, that means the second print function has been called and it is printing 500.263. And in the last case, it is printing this hello C++, so printing character, so it is printing character, so hello C++ is getting printed accordingly. And this is known as function overloading. In case of function overloading, the same function name will be obtained for multiple number of times, but the function prototype must be differing in their input arguments. In this way, we have explained this program line by line and you have got the clear idea what is a function overloading. Thanks for watching this video.
C++ function template.
So here we have defined one template. Here this is the max function which takes const reference A and const reference B of type T, and it will compare A and B and the maximum of them will be returned, and which is quite obvious from the name of the function. So that's why the output argument is of the type T const reference. So now here you see template type name T, so we have defined T in this order. So now here if we pass two integer data to this max as input argument, then in that case the max will find out the maximum of I and j. The max will find out the maximum of I and j and the value will be returned. So here 39 is greater than 20, so 39 will be returned here. In this case, it is taking two double as input arguments, so 13.5 and 20.7. So 20.7 is maximum than 13.5, so 20.7 will be returned here. Here we are having two string, so one is our hello and another one is our world. So according to the alphabetical order, world is higher than hello, so that's why world will be returned in this case. Here you see, here with this max function, we are passing two integer data, here two double data, and here we are passing two string data. So as a result of that, as we have defined this template, so we need not to define three prototypes of this max function. So for the better understanding, let us execute the code and we should show you that at first it is returning 39, then it will return 20.7, and then the last call it will return world. So here is the output for us, and from here it is quite obvious that why these outputs have come, because we have explained that one logically line by line.
C++ inheritance.
Let us explain this program. Here we are defining one class known as the base class, and this class is having the name shape. Under the public section, we have defined set width one member function, set height another member function, and two variables under the protected section, under the protected scope. So here we are having int width, int height,
This set width and set height, they are taking the respective values as input argument, and those values are getting assigned to the respective member variables. And that is the purpose of this two setter functions, set width and set height. So name of the class is shape, and this is a base class because this particular shape has got inherited in the class rectangle under the public scope. So shape is the base class, rectangle is the derived class, and this rectangle is inheriting properties from shape, and here we have defined this public scope here. So as a result of that, all the public members of this shape will be coming to the public section of this rectangle, and all the protected member variables will be coming to the protected section of this rectangle class. So here we have defined one extra member function under the scope, under the section public. So return, which is returning the product of this width and height as output argument. So that's why int is the product data type. So now in the main function, we have defined one object under the class rectangle. The name of the object is rect. So we are calling this setter functions, as these setter functions got inherited in the public section. So object name dot operator using, we can access them as well. 5 has been passed as input argument to this set width, and this 5 will be assigned to w, and that will be assigned to the member variable, that is our width in the class. So in this way, the set height is taking this 7 as input argument. So this 7 is getting assigned to age, and then it is getting assigned to the height member variable. So now after getting them, we are calling this rect dot get area. You can find that this get area is also under the scope public. So as a result of that, it is accessible from the outside of the class through object name dot operator. So in this way, the total area is getting printed by multiplying this width and height. So for the better understanding, let us execute our program. So that's why we have clicked on compile and run option. And we know that if we keep the value 5 and 7, then the respective area after multiplication will be obtained as 35. Let me execute the same using our GNU C++ environment. Okay, so here we are having this particular options. So now here the program name is proc63. So going for G++ proc63.cpp -o a.exe will be the output file name. I'm going for the compilation. Compilation has got completed successfully. Now I'm executing. I'm getting the same output as I got in case of deb C++ execution, that is 35. In this way, this program we have explained line by line, and also we have shown you the output after running it in the deb C++ IDE and also running it using GNU C++ compiler.
Function like macros.
So here we have defined one macro using this hash define, and here mean a comma b will have this particular respective body. That means if a is less than b, then it will return a, otherwise it will return b. So now this is the respective body here we are having. So prior compilation, when the preprocessor will come into the play, it will replace this occurrence of mean in our code somewhere with the respective body as this one. So that is known as a macro here. So each and every occurrence of this mean I comma j or any other arguments, whatever we will be using in our code, will be replaced by the respective body by the preprocessor prior compilation of this code. So now let me execute this program. So as we have put the value 100 for I and 30 for j, so obviously the j will be returned and it will print the minimum value as 30. So in this way the program can be explained, and this is known as macro substitution.
C++ function call by pointer.
Now in this program we are doing something little bit different from the previous one.
So here we have defined the variables a and b with the values 100 and 200 as usual, but printed their respective values. So now instead of passing the values in a and b, so here in case of we are passing this ampersand a and ampersand b, that means the address reserved for the variable a and address of the memory location reserved for the variable b as input arguments. We know that addresses don't have any data type. Its content will have the data type. So that's why to get the content of an address, we use the operator pointer. So int will be the data type of the value residing at that very particular address pointed by this variable x. So that's why ampersand a, this thing will be received with this particular format, that is int pointer x. The b address will be kept in y. So content of the address will be of the type integer. So address of a will be content in x and content of that address will be of the type integer. So in this way the things are taking shape. So here we are printing the values of a and b. Now we have passed the addresses of a and b as input argument to the swap function. So these addresses are getting assigned onto this x and y. So if you want to print the respective values in those addresses, then obviously you are going to get 100 and 200 respectively. Using the third variable, we have swapped the values of this pointed x and pointed y. So now after swapping, we are printing the respective values of pointed x and pointed y. So we are expecting that the value would get swapped in the meantime. So it will get printed not 100, 200, but 200 and 100 in this order. So before swap the value of a is 100, before swap the value of b is 200. Within swap function, before swap operation, the value of pointed x is 100, pointed y is 200, and in this way we are printing. And now within the swap function, after swap operation, the value of pointed x is 200 and value of pointed y is 100. So now when we are returning back, then when we are printing the value of a and b after swap, we are finding that the values have got swapped accordingly, because this x and y, they are holding the addresses of the variables a and b, and the updates have been made against those content of those memory locations. So as a result of that, when the control will be coming back to the main function, the variable a will be having the updated value 200 and variable b will be having the updated swap value of 100. In this way the values have got swapped. So we have explained this program line by line with the output or screen, keeping that one side by side. I think now the concept is now getting clear to you.
Define C++ objects.
Let us discuss on this very program. Here we have defined one class. The name of the class is box. Under the public scope, we have defined three variables of double type: length, breadth and height of the respective box. In the main function, we have defined two objects under the class box. So these objects are box1 and box2. Also we defined one volume variable under the data type double, initialized with value 0.0. So the first object box1, the respective attributes, that means the member variables length, breadth and height, they have got initialized with the respective values. Similarly, we did the same for box2 object also. So now we know that to calculate the volume of a box, we need to multiply height, length and breadth. So we are doing the same to calculate the volume, and then the volume is getting printed, and we did the same for box2 also, and the volume got printed accordingly. So at first we are going to print, they are going to multiply this 5 into 6 into 7, so the respective value will get printed accordingly. So now let us go for the execution of the code. So we are going for the compile and run option. So for box 1, the value is 210, and it is quite obvious because 5 into 6 into 7 is equal to 30 into 7, that is 210. And in this case 10 into 12, that is 120 into 13, that is 1560. So in this way the values have got calculated. So this program depicts that this particular class box containing three variables
member variables under this class defined under the public scope, and these member variables have got initialized when we defined objects, two objects, box 1 and box 2, under the class box. And then after initializing all these member variables, we calculated the volume here. As these variables were under the public scope, so they could have been accessed using object named dot membership operator, and in this way the volume got printed for both box 1 and box 2. So now let us execute the same program in GNU++. So here is the output for us. So G++ will be the respective compiler name. So here it is prog61.cpp minus o a.exe will be the output file name. So now let me execute the code after compilation. So compilation has got completed. I'm just executing a.exe and we are getting the same output as we got in case of dev C++ program compilation output. So in this way, this concept has become clear that how the member variables of a certain class can be initialized through the objects and using the dot membership operator.
C++ function call by reference.
Let us explain this program. So here this value of a and b, two variables, are 100 and 200 respectively. We have printed their values. So now in the swap function we are passing this a and b. Look at the prototype. So void swap int ampersand x int ampersand y. We know that in the prototype declaration these variable names are optional. We may also omit them. We could have written this one as int ampersand comma int ampersand also. So whenever you are writing this particular thing, that means we are calling by reference. The function is calling by reference. Call by reference means a same variable which will be occupying one-time memory space allocation will have different names from the different scope of the program. From the main function, the memory locations will be known as a and b, and from the swap function the same memory block will be referred to as x and y, and that is actual concept of call by reference. So now when you are passing this a and b as swap a and b, swap is a function, a and b are two arguments we are passing, and then we are finding this swap, receiving this a and b into x and y with the syntax int ampersand x int ampersand y with these references. So temp is a local variable. So before swapping we are printing the values of x and y. Through this temp, using the third variable, we have swapped the values of x and y. After swapping we are printing the values of x and y and we are returning the control. After returning the control, we want to see that whether the values of x and y, which was referring actually the variables a and b, whether these values of a and b variables have got swapped or not. So I think the conception will be cleared if you go for the execution output. So in the execution output, you can easily find that we are printing the values of a and b as 100 and 200 before calling the swap function. Within the swap function, x and y, they have got the respective values of a and b, that is 100 and 200 respectively. After doing the swap operation using the third variable, the values of x and y have got changed, have got swapped within the swap function. After returning back to the main function, when the control will come back to the main function, if I want to print the values of a and b again, I am getting the values of a and b swapped. So this is a good example of call by reference. So I think now the conception is cleared because we have explained line by line and along with the execution output. Thanks for watching this video.
C++ function call by value.
Now let us explain this program. So here two variables a and b initialize with 100 and 200 respectively. Before calling the swap function, we are printing the current values of a and b. So you are expecting that a will be printed as 100 and b will be printed as 200. In the swap function, a and b, they have been passed. So this a and b will be getting assigned onto variable x and y respectively. So before doing any swapping operation, we are just printing the values of x and y variables. So we are expecting that x and y
will be printed as 100 and 200 respectively. Now using the third variable, we have done the swapping. Now after swapping, we are printing the values of x and y. So we are expecting that x and y, they are going to get printed as 200 and 100 after getting swapped. Okay, now see. So here is the respective output scheme. So 100 and 200 is getting printed. Before doing the swap operation within the swap function, the values of x and y will be 100 and 200 respectively. So within the swap function, after swap operation, the values of x and y will be 200 and 100. Now you see, after swap, the value of a and b, after returning back, because here we are having the return statement, so control will be transferred to the next line of the swap function calling statement. So here we are printing this value of a and b, and here we are finding that it was true that x and y, they have got swapped, that the values of a and b, they are not swapped, because a and b, they are the local variables within the main function, and x and y, its scope is confined within the swap function only. So a and b, they are local within the main function, and x and y, they are the variables having got the scope confined within this swap function. So they will have their respective different memory space allocations. So whatever the swapping we did will be in the memory locations reserved for the variables named as x and y. So when we are coming back to the main function, after returning back, when we are supposed to print the values of a and b, it is getting printed from their reserved locations which are not getting updated, which had not got updated. So again, the value of a and b, they are being printed as 100 and 200 as we have mentioned here. So this is known as call by value. That means the values of the variables a and b, they have got passed to the variables x and y respectively. I think now the program, this particular logic of this program is now clear to us. Thanks for watching this video.
C++ accessing structure members.
In this program, we have defined one structure. The name of the structure is books, and it is having 4 fields which are defined under this books structure. So struct books, and then we are having this character title one array consisting of 50 locations. Similarly for author and subject, subject is having 100 locations against this character array, and one int integer variable, that is book id. So we are having 4 fields against this particular structure books. So now within the main function, we have defined 2 structure variables. One is the book 1 and another one is the book 2. So now each and every field of book 1, they have got initialized as they are of the type string. So as it is a character array, so we could have used this strcpy, that is string copy, to keep this particular name as a book title, keep this particular name as the author of the book, and this is the subject title. And in this way also we have defined, or we have initialized this book id with this particular integer value, as book id was of type integer. So similarly we have used the same strcpy to initialize first 3 fields of this book to structure variable, and the book to book id has been initialized with some integer data. So now here we have print the info against the book 1. So that is the way to print it. It is very simple. That is a structure variable name dot title. Here dot is denoting the membership operator. So again we are having this structure variable name dot author, structure variable name book 1 dot subject, structure variable name book 1 dot book id. In this way we have printed all the 4 fields value, and similarly also for the structure variable book 2. So now let us execute our code and let us see that how these values have got initialized into the fields and how the values have got printed. So here you see all these 4 values have got initialized, have got put in the respective fields, and also these values have got put in the respective fields and they have got printed accordingly. I think now this conception against this particular structure is now clear to us.
C++ assignment operators.
Let us explain the execution of this program now. Here we are having this int a is equal to 21, int c, which is uninitialized, c is equal to a. So let me execute my code so that we can get the idea that how the outputs are obtaining. So I'm executing my code now. So this is the output screen we are getting. So also I'm putting this notepad side by side to do any rough work. Okay, int a is equal to 21 and c is defined but uninitialized. C is equal to a and the value of c has got printed. So c has got printed as 21. C is plus equal to a, that means c is equal to c plus a. So c is having value 21, a is having value 21. So 21 plus 21, 42 will be the new content for c, and that has got printed here. Now c minus equal to a, so 42 minus 21. So c is equal to c minus a, so 42 minus 21, so 21 will be the new value for c. So 21 is coming for the new value for c. Now c star equal to a, so now c is having the value 21 and a is also having the value 21. So 21 into 21, the multiplication is taking place, and that is 441. So in this way you are getting this 441. So now c slash equal to a, that means c is equal to c by a. So that means 21 squared by 21, so that is 441 by 21 is equal to 21 will be the new value for c, and yes, the value of c has got printed as 21. Now c is equal to 200 and c percentage a, percentage is equal to a, that means c is equal to c percentage a. That means the value of 21, this particular value 200 rather, will be divided by 21, and the remainder whatever is getting obtained, and that will be assigned to c. So the value of c has become 11 in that case after doing this remainder operation. So c, there is a left shift equal to 2. So that means that we are going to shift the value of c towards the left hand side for 2 bits place. So we know that 2 bits place left shift means 2 to the power of 2, that is 4 will be multiplied in the resultant value for c. So 11 into 4, so the output will be 44 in that case. So now again we are doing the right shift for 2 places, and as we are doing the right shift for 2 bit places, so that 44 has to be divided by 2 to the power of 2, and that is 2 to the power of 2 means 4. So again we are getting back this 11. Now c and 2, so 11 means we know that if you write 11 in byte form, and that is 8, 4, 1, 2 and 1, so it is 11 is nothing but 8 plus 2 plus 1. So that's why I placed 8, that means 1 I have placed in the position of 8. So 0 I have placed in the position of 4, and in the position of 2 and 1 I have placed 1 and 1. So now if it is getting ended with the value of 2, so that is 0010, then I'm going to get, after doing this ending, I shall be getting this 2 as a result, so which is nothing but 2. So that's why after doing this AND operation we are getting this 2, and then we are doing this XORing with 2. So we are doing this XORing, so 2 XOR 2, always it will be 0, because similar bits XOR will produce the output 0 in that case. So if we do the XORing between these two, if we do the XOR, then obviously the output will be 0. So similarly I'm getting this value c is equal to 0, and in the last we are doing this ORing with 2. So with this result, if we do the ORing, then obviously the output will be 2 again. So in this way the output has become 2. So in this way we have explained that how the outputs are coming, and the same outputs will be obtained in case of GNU++ if you go on compiling our program in GNU++. So in this way we have explained our code with the proper tracing, that how the values are getting generated.
C++ class template.
In this program, we have defined this T as a generic type name. We have defined one class named as stack, and which is having the private member, that is vector elements, and what kind of data we are keeping in this particular elements will be of generic type. So now under the public section we have defined function number 1, that is push, function number 2, that is pop, and function number 3 that is empty. So in this way we have defined this respective class, and in the outside of this class we have defined all the member functions with the respective body. We know that this is colon colon, which is denoting the scope resolution operator, and here we are having this void stack t. As I told you that t is the generic type here, and under this particular stack class we are having this push method, the member function, and this is the respective body here. So ELEMS is nothing but a vector object, and pushback is the respective member function which is already defined under this vector object. So similarly we have defined this pop function, also we have defined this stop function, and which will check whether this vector object ELEMS elements is empty or not. If it is empty, then it will throw one exception, that is out of range exception. So now in the main function we have defined one object under this particular class stack, and here we are doing this data type binding, that is int type, and stack string stack. So here we are defining two objects. We are defining two objects under the class stack, one with the data type int, another with the data type string. So now here we are pushing this int stack, here we are pushing this value 7, and then we are just printing the topmost element of that. And in the string stack we are pushing the value, that is string value, that is the hello, and also we are printing the topmost element's content. Now we are popping out the first element, and that will be popped out, and the second time we are calling this particular pop. As we have found that we have pushed only one element in the string stack, so the first pop will work, but the second pop will produce one exception, and that exception will be handled. And in this case this is the exception const reference ex, and here ex dot what. So this is the respective method which is already defined under the exception, and here you see we can find this one, that when we are popping and we are throwing one exception whenever we are finding that elements dot empty is returning true. So now let me execute my code for the better understanding. So if I do the compilation and execution of the program, then we are finding this one in this way. So the first two push operations will be done perfectly okay. So 7 and hello, so 7 has been popped, so we have pushed the value 7 at first, and then we just print the topmost element, and that's why we got this particular value 7 here. And then we push the value hello here on the string stack, and then we have print the topmost element using the function member function, that is top. So that's why hello got printed. But when we are trying to pop the first element from the string stack, so the hello will be popped out, so that will be no exception. But whenever I shall go for the second time pop method call from the string stack corresponding object, then obviously that will produce one exception, and this exception has been handled here. So in this way we have explained this program line by line, and this program depicts that how this template can be used as a generic data type for the class also.
C++ calling a function.
Now let us explain this program. So int a is equal to 100 and b is equal to 200. Rate is another variable defined. So in the max function we have passed the values of a and b. So this a and b, they are supposed to get assigned to num1 and num2. So now in the parameter num1 and num2, they will get initialized with the current values of a and b. That means they are 100 and 200. So now we are checking the value of the comparison of between this num1 greater than num2. We know that 100 is greater than 200. This condition is false. So the control will be coming to the else part, and result will be equal to num2, that is 200. Otherwise the result will be equal to num1. So the result will be assigned with the current value of num1. So here this particular condition is false, so control will be coming to the else part, so result will get initialized with the current value in the variable num2, and the value of result will be returned. The return value of the result will be assigned to the rate variable, and ultimately the value of the red variable will be getting printed. So you are expecting that out of 100 and 200, 200 will be the maximum value, and it has got printed accordingly. So now let us go for the tracing of this program, which will help us to know that how the parameters are getting passed. So to enable the tracing mode, we shall have to go to Tools, Compiler option, and then Settings, and then Linker. Then the second option, that is Generate Debugging Information, it has to be made yes. If you load this dev C++ on your system, by default all these options will be initialized with no initially. So for this one you should have to make that one yes and click on OK. So we came from compiler option, then settings, and then linker, and then the second option here. So I've made that one yes. Now I'm putting one breakline here. So this is a breakline from where the program execution will be initiated. I'm coming to the debug mode, and here I'm going for add watch. I want to watch variable A, variable B, variable RET. Also we can do in this way, we can select this num1 and go for this one, and in this way also you can add watch. Okay, so we have taken this A, B, rate, num1 and num2. So all the variables whatever we are having in this main and this max function, they have got listed in the add watch. So now I shall be going for the debug mode. I shall compile my code once, then I shall go to the debug mode and I shall click on debug. You see my tracing bar has come up to this line. So A and B, they have got initialized with 100 and 200, and rate is uninitialized with the value 0. So now I'm going for this into function. So this A and B will be assigned to num1 and num2. So num1 and num2, they have got the values 100 and 200. So now you see num1 is greater than num2, 100 is greater than 200 is false. So result is going to get initialized. So here let me add another one, that is a result. So here you see result is still with the value 0 because this line is supposed to get executed but not executed yet. So whenever I'm just crossing this line after its execution, the control has come to this statement, that is return result, and result has got value 200 already. So this value of result which will be returned will be assigned to the rate variable. So let me check that one. Rate is still with the value 0. So we're going for this one. So now you see rate has got the value 200, and this is the line which is getting printed. So this is a line which is getting printed. You can also see that one in the output. We can also see that one in the output. So this line has got printed. Now the contour will be coming to the next line. So that is so after this max value, the value has got printed and return 0. So now we are going for this continue. So the program has got its execution accordingly. So in this way the program has got its execution, and from the tracing it is quite obvious that how we have got the values and how these parameters A and B here from here they have got assigned to num1 and num2. I think through this tracing, the execution, how this execution has taken place, it is now clear to you.
Default values for parameters.
At first we are considering the function sum. So int is the return type argument for sum function, and int a is the first input argument, and another one is your int b. But this int b is having some default value, so that is equal to 20. So this b is having a default value. This parameter is having a default value of 20. So int result is the local variable within the sum function. Result is equal to a plus b return result. So now from the main function, this particular sum function will be called. So a is equal to 100, b is equal to 200, int result. So whenever we are passing this 100 and 200 through a and b to the sum function, so sum function will do the sum and it will perform the addition of 30 as result, and that will be assigned to result, and that will be returned. So the return argument will be dumped here onto the variable result. So when this result is going to get printed, so we are expecting that it will just print 300 as the output, because we know that 100 plus 200, 300 will be the return type argument, and that will be assigned to the respective variable result here. Okay, now see, in this case we are passing only one argument. Other argument we are not passing. So here we are passing only 100 through A, and other argument we are not passing. So the default value, which is 20, will be now coming into the action. So now this 100 plus 20, 120 will be the sum that will be dumped onto the variable result, and the 120 will be returned, and that will be coming to the variable result, and result is going to get printed. So in the first sum, the sum will be 300. In the second case, when we are calling the sum with one parameter, with one argument, that is A, with the value 100, so the second parameter, the second argument will be taking the default value 20. So the total value will become 120 in this way. So thus we are getting this proper explanation why these outputs are 300 and 120 when you are calling the function with two arguments and one argument respectively.